it looks so much cleaner now. I spent
that's amazing.
3 hours with a hose, a paintbrush, and a whole lot of simple green. What's up, Charles? And it's still gross. So I still think that like we're gonna spend some time with some simple green and a toothbrush, getting the last little bits clean. Like I'll see if I can get the camera to focus on it. Like there's still some nastiness down here in this corner that I missed. Oh, the camera's probably not going to show it great, but right down in here in this bottom corner is very gross still. And we still have some grossness on the far side over there.
Yeah, it's tricky that it's like just blank aluminum, because for the machines I have where it's all chromated, I occasionally just use dilute bleach on just the chassis and just let it soak for a bit and then hose it down, and it would get rid of everything.
Yeah, I'm not sure how diluted bleach would do on raw aluminum.
No, you don't want to. It's very basic, so it will start attacking it right away.
Oh
yeah. But this is not the big worry here. The frame is, I mean, you can see it cleaned up decently, all right, and
yeah.
A little bit of scrubbing and it'll be fine, I think. I'm not afraid to touch it anymore. The problem is this big honking dude right here. That was loud. Sorry.
Yeah. Just a little bit. It's all right.
Yeah. This big dude here is the problem. I am not entirely sure that's savable. I'm actually going to get some gloves to mess with it.
To be honest, I don't immediately see anything wrong, but it might just be the low resolution here.
That transformer looks like the
yeah, that's rusty.
Yeah, look at the transformer.
So everything else I think I could probably bring back. The transformer's the issue. The rust on the plates sucks. It'll be noisy, but like that's not a huge concern. The bigger concern is that all of the paper on the windings has pretty much disintegrated. I'll take a couple pictures and post them up in Friday night chat here.
And that was from it being stored outdoors?
And me washing it with the hose didn't do it any favors.
No,
but yeah, mostly this thing was stored outside for probably 20 years. I mean, Texas is a pretty moderate climate, so things like this die at a much slower rate.
Oh yeah, than here where if I left one of the machines outside for a couple days.
Yeah, but I mean,
would eat it.
This thing was filled with leaves and tree junk and all sorts of stuff. It was very gross. It took a lot of cleaning to get it there, and I mean, everything is still very crunchy on it. The fuse holders here have fallen almost completely apart. But the transformer is my big worry. I posted up some pictures in the Friday night chat there. I'm not sure if we've had corrosion. I mean, the paper is still probably a little wet, which is going to make a hilarious problem if we power this up. So, I mean, the windings should be laminated copper. And so if the paper's a little destroyed, it shouldn't be a big deal. We shouldn't have any shorts. But there could be corrosion on some of the windings somewhere that I can't see. They could be shorting some of the windings out. So it could be, a nice spark show. And this is only part of the power supply. You can see there's two edge connectors up here, right at the very top, whenever the 15-second delay on Twitch catches up. In those places go these two regulator cards right here, which are also a disaster piece. One of the, I'll take a picture and post these up there as well, because it is rough. So my thinking is that likely the power supply is not savable, but maybe we'll send it and see what goes up in smoke anyways. It's a nice night out, so if I have to open the window, I can.
What?
I mean, if you clean it, it's probably savable. I don't know about the transformer, but those boards, the capacitors might be damaged, but otherwise.
Oh, I'm not so much worried. I mean, yeah, the capacitors are probably a bit of an issue. The bigger problem is that I'm seeing lots of corrosion. And so there's a strong possibility that we have some traces that have corroded through, and I just haven't seen them yet. I've also got multiple transistors that have fully rusty bodies, which means that we could have a pinhole through the transistor, which would then kill the silicon on the inside of it. And I'm seeing that on 4 or 5 different transistors for certain. So I mean, like, yeah, we could probably bring this thing back, but it would be a very long, arduous journey for sure, with lots of replacements having to go in.
Yeah, you've definitely got leaked electrolyte from a couple of caps there. So
Yeah, the one in the middle of the board on the right is
Yeah, this guy up here has pitted the I guess it's not copper. Well, it's copper, but it's whatever the plating on the copper is, it's almost completely destroyed that.
Yeah, so the corrosion looks worse than it is because that's probably just tin plating, which is way easier to corrode than the copper.
Yeah.
I've had a number of boards that look like this from kind of same storage conditions, except here in the Netherlands, which is worse climate. That ended up working just fine after a alcohol a drying bath and then a short bake.
Yeah, I mean, I'm willing to plug it in and send it tonight just to see what happens. I mean, I can see on the backside of this one, I can see quite a lot of rust starting to form around many of the pins and traces here. Those are rough. But yeah, I mean, you know, if it's dead, then we got nothing to lose. And if it's good, then we can, you know, fix the few things that are bad on it, that are broken on it, right?
Yeah. What's what are the out? Do we know what the output and current is? Like the voltages and current?
Yeah, so that's my fallback, right? Is if we can figure out what the outputs are supposed to be, this box that holds the transformer is huge, and so I could just fill it full of mean wells, right? But I have to make a new. Oh, let me tip it up on its side here. I have to make a new PCB that the mean wells plug into because the power supply itself plugs into the backplane via a card edge connector down here. So if we're going to do that, then, you know, one of the things that we'll do tonight is we'll pull that PCB out and try to figure out what outputs are going out on it. Because if there's like 5 voltages or whatever, like we can make those 5 voltages pretty easy, but there might also be like a DC OK, an AC OK, or a sequencing signal or something like that goes to the main machine. The good news is that I don't think there's not a power switch on the front of it. Oh, there is a power switch on the front of it. So yeah, somehow a power switch comes into this via the back plane to turn it on. Plus you've got the breaker and the stuff in the back. So you've got some input flipping something on via the card edge connector on the bottom here. Oh, jeez. Even after a big wash, all the switches on this thing feel atrocious.
Oof.
Yeah, they're gonna need a lot of cleaning. All right, camera. You can figure out how to focus. There you go. Yeah, so I mean, I figure we don't really have a whole lot to lose.
Yeah.
We can slot the boards in, plug the boards in, and then give it a whirl, girl. See how it goes.
Ooh.
Still might not be a bad idea to reform the capacitors and check the isolation of the transformer with a meter first.
Yeah, I'd be a little concerned about putting all that 7400 logic
Oh no, I'm
on
saying
power.
we power up the power supply with none of the PC boards plugged in.
Yes. Yeah, no, that's a good idea.
No,
Yeah.
we're not doing anything with the PC boards until we're certain that we have good, clean power.
Good. Okay, yeah. I'm with you now.
Yeah, no, I'm crazy, but I'm not dumb.
Yeah, no, I know that. That's why I was a little surprised. Like,
What's up, Bob? What's up, Thermal Dragon? Oh. Yeah, Philip, there may indeed be tin whiskers growing on some of these. The hope is that they'll burn themselves out, or whatever goes bad will let us know what went bad by catching on fire, and then we'll know, hey, the component that caught on fire was bad.
So is there any reason you're not gonna try to slowly reform the capacitors, or at least check if they're good?
Because they're a right pain to get out.
Fair enough.
I mean, I can't get to them from behind, so I would have to fully remove that PC board in the back, which means that we're gonna have to desolder a few wires, because these guys here are soldered in with no plug anywhere. They just go straight to somewhere, and those are the two wires that go to these two diodes here. So we would have to desolder these wires, unplug that, and then there's 6 screws or 8 maybe around the periphery that we would have to take out, and then finagle the thing up and out. Oh, and there's another wire down there. Yeah. I mean, there's sprayed caps. If anything's got a chance of, not needing to be reformed dramatically, it would be a sprayed cap.
yeah.
But those big smoothing caps are the least of my worries. Everything else is going to catch on fire before we ever get to those.
Fair enough.
That's not so much paper as it's pulp.
Yeah.
Yeah.
I mean, it might have been paper at one point. It's not paper anymore.
So I'm a bit worried about if the lacquer on the windings could handle it, but what I usually do to dry stuff is to just soak it in isopropyl alcohol after the water wash, and then
I
heat it a
spent
little.
a decent amount of time with a leaf blower and then a air compressor, but I mean,
Yeah,
you can only do so much, right?
Yeah, the isopropyl really helps because it displaces the water, and then it's easier to evaporate itself. But it only works if you don't have anything that's soluble in it, of course.
Yeah, I'm not worried too
Yeah.
much
Like
about water.
90 something today.
Yeah, I had it sitting in the sun for several hours too, so.
There's no sign of a part number or any information on what windings and ratings that transformer has. Is it-
Not that I can see, no. It does look like there's not a whole lot of secondary windings coming out of it. I mean, there's not that many wires coming out of it, but yeah, because that's going to be input, and then we've got, yeah, not a whole lot. It's almost like it just creates one big voltage that it then cuts down into several smaller voltages on the regulator boards, maybe.
And if it's a common voltage like 12 volts, it would be easy to replace it with a transformer out of like an old battery charger.
Yeah. I'm willing to bet that we got a lot more voltages that we need to generate ultimately, though. But I mean, yeah, I don't know what they're doing on the control boards.
I really hope that it's not like the HP machines where you have to somehow generate -2 volts.
Yeah, I don't know. I was hoping that we could
Yeah, they
find
opened.
some documentation on the TI-980, and I found some stuff, but no like schematics or anything.
No.
It would sure be nice if we had a schematic for the power supply.
Yeah, on the back plane between the edge connectors, is that a legend that says what signals they are? the text?
Let me move this out of the way. See if we can figure that out.
It looked like it from a distance.
It has a battery test button, which makes me wonder if it had an external battery pack.
It did. There's a plug on the back of the power supply that says battery.
This is a semiconductor RAM. It's not core, or is it core?
That's right. No, it's
Okay.
It's DRAM.
Interesting.
Jeez, I'm still like popping bits of branch and stuff out of this thing. The backplane unfortunately does not instruct us as to what the output voltages are. I can see that there's a ton of ground pins, so we know where the ground pins are. The backplane is fully wire wrapped. I don't know, you guys get a little bit of a view of that.
Sorry for the confusion. I meant the backplane in the power supply. It seemed to have a couple of rows of vertical text between the two connectors.
Oh, you're talking about different backplane. Gotcha.
Retired Tom in the Twitch says he has a power supply manual with schematics.
Oh, heck yeah. Can you share that? In Twitch
Roy's
or on?
asking for links. He's in the Twitch chat.
Oh, excellent. Oh, they're on archive.org. If you can drop a link, Retired Tom, that would be excellent. Or if you're on the Discord, you could just drop the PDFs into the Discord. That'll work too. So the text I think that you were talking about is just like patent text. It does tell you what schematic number to look for though, which is schematic number 226833. Yay.
Oh, here we go. There's also some. Hang on.
Well, dang! If we're finding schematics,
Yeah.
let me get the other laptop out right quick, so I can see what's
What
going
was the
on.
number again? The schematic?
226833. Let me get a power strip here. All right. If it's just like 4 voltages with no DC OK signal, I'm pretty much just gonna swap everything with Meanwells.
It probably makes the most sense. It looks like it's primarily 5 volts because I see references to on the TI-980A. This is 980A physical characteristics. There's CPU control AU1 is 5 volts at 14 amps. AU2 is plus 5 volts at 4 amps. The memory control is 4 amps. 8K module is 1.5, and the I/O interface is 0.5. And then there's other stuff as you go.
There's no other.
Also,
I mean, surely there's like a 12 volt or something going on as well, right?
Oh, there's got to be because
And a
it
negative
mentions
5.
RS. Yeah,
There's plus minus 15. So I'm looking at the power supply technical manual. It has full theory of operation as well, not just schematics.
where is
All right,
that?
let me pull up my.
I'm looking at bit savers. I'm hoping I'm looking at the right thing, but the pictures seem to match. I'll share the link.
Okay,
Excellent.
Let's see.
I did
Should've
not
done
see
more
anything at
reading.
first. I was doing some reading today pre-call, so I knew what the heck I was talking about for once. And
Where do you want me to drop it? Friday Night Twitch.
Yeah.
yeah,
So there, and then the document I have open right now.
I got attacked by a spider. That's fun.
that does look similar.
So this document seems very informative about this.
It's got two 15-amp fuses. I don't know if that helps.
I've got a block diagram here. I'm going to zoom in on it and share a screenshot.
Okay. So that's pretty standard.
Oh, both of these laptops need updates. Yeah, I know. I'm getting there. Slowly. New one, Fairlady Z. Let's actually open up Twitch chat since I got this one going. So that way I can see Twitch chat big instead of small. Retired Tom, thanks for the link. I think that might be the same one that was posted potentially.
Yeah, the link I posted here, the upper one is an open dir that has more schematics as well. So, but yeah, that's just on bit savers, which is really one of the first places anyone should be looking who's working on old stuff.
I feel like a forensic specialist wearing like nitrile gloves while using a laptop.
This manual is written almost like an electronics textbook.
Nice.
It's explaining every little bit of the circuit and showing the computations for like why the values are what they are.
Oh, there we go. Well, no, that's the overvoltage. Oh, but it looks like we've got two +5s, a -5, and a +12. That's like pretty dead nut
And
simple.
15. Plus minus 15.
Are the 15s sent out to the machine, or are they internal to the power supply?
That's a good question.
Oh,
by the way, there is a test procedure.
Not sure. So there in section 4.3, there is a logic control signal section. So AC on, low when the AC is on, all reg up. The signal goes low after the main voltage is up and all others. MP lost when the battery voltage is lost. Master reset, on delay, overload, power off. Reference enable, and reset switch. Also up delay minus. So there's like quite a bit of power supply sequencing.
Yeah, but the question is what gets sent to the computer? Like the power supply sequencing may all be happening internal to the power supply.
Oh, that's true, because it says logic control signals used in the power supply.
Yeah, and if we're replacing the full power supply, all we care about is what gets sent to the main boards.
Let's see.
I'm looking now.
Schematics are page 85 and on.
Okay.
Page 85 seems to be schematics for like that backplane in the power supply. I think the connector going to the rest of the system is P2. So I see a plus 16.2/12. Not sure
That's
what
a-
they mean by that.
That's a weird
5
one.
volt standby, -5, 19.5.
Ooh, there's some AC on there.
Whoa. Whoa.
Yeah, there's a plus and
the-
minus 25 AC.
35, I think.
Are we
Pin-
sure that that's what
Pin
go? I
21,
mean,
22, that's 35 AC. And the plus 15, minus 15, yeah, because look at the page 85, which is 501. The P2, like there's a box below that, and that has inscribed in its CPU back panel ASCII. So that is definitely the connector going out to the rest of the system.
okay, yeah, I gotcha. So yeah, there's actually quite a lot that's going on.
Yeah.
There's plus
I
5 and ground, obviously, those are the big boys. The plus 16.2 and 12 is a weird one. Then you have plus 5 standby and -5, those are easy. The plus minus 25 VAC is interesting. We can probably knock that out with a like a doorbell transformer.
Yeah.
And then I don't know what the MP set is. I can't quite read that one.
M reset,
Oh,
M
M
reset.
reset.
MP off, and reset SW. So looks like the reset signaling is going through here.
That's fun.
Yeah, I'll rig up AC on and I'll rig up also. Which you
Yeah.
can fake that's like not a I don't think that's a big deal to fake.
Wait, where did you get AC on and all rig up? Those don't seem like they're going out to the computer.
Am I looking at the wrong?
Yeah, that's the connectors for the boards in the PSU.
Oh, you're right. You're right.
computer
You're right.
one's all
I'm
the way on the
flipped
bottom.
over.
Oh yeah. If you're at the
Um,
top of the schematic, those are the regulator boards that plug in.
I am seeing a few things that will need to be taken care of if you try to run it outside the system. There's a external sense line that would need to be bridged to the 5 volts, and some of the signaling lines would also need to be connected.
Well, most likely we'll plug it into the backplane without having any of the cards into the backplane, and that might get us most of the way there.
Yeah, there are testing and testing procedures in one of the other sections.
I mean, can we not just send it?
I would just
Yeah,
send
fair.
it. That sounds like fun.
But yeah,
I'd
with
just
power
send it.
supplies like this, I've spent hours debugging a working power supply because I didn't have the minimum load on there, and it just shut down immediately.
I mean, if it just shut down immediately, that would be an indication that we're on the right path at the very least. Like, I'm expecting fire and brimstone.
Fair enough.
I've seen
So, like,
worse,
interesting.
I've seen worse looking transformers.
I mean, yeah, it's not great. it's
It's
not the
pretty
worst,
bad.
but it's not great.
Yeah,
wonder
those
how our
PSU
fuses
paper
are.
worries me.
So F3 is good.
Well, it is supposed to be 100 degrees tomorrow, so fire and brimstone could be a little aperitif for that.
Yeah, ain't that the truth, man? It was hot today. Well, I'm not going to pull that fuse out because the holder is broken. So we're just going to have to hope that that fuse is fine, like the other two.
They do instruct you on how to run the power supply without the 5-volt main regulator card. It's on page 45, which is the first part of trouble analysis.
We don't know that we're in trouble yet, though.
Oh, fair.
I mean, pretty obvious that we're in trouble.
Are there any date codes on this power supply? Like when are the ICs manufactured or anything?
Some of the transistors got 72 on them. I see 72 on the caps. Let's see, this guy over here. We've got some more 7210s. 7218. So 1972 is looking likely.
Okay, yeah, that's a couple years older than anything I've worked on.
Yeah, it's pretty old. I mean, we could probably restore it and get the power supply going. If the transformer didn't look like hot garbage, I would be a little more inclined to put extra time and effort into it. But I mean, this whole thing looks like, oh, oh, that's broken. That's fun. It's just a little line filter cap.
I'm really not too worried about the transformer. Assuming there's not a ton of water in that paper anymore that's going to corrode it when power's on.
There's probably a ton of water in the paper. I mean, the whole thing was drenched, soaking wet.
It'll be fine. Send it.
I mean, you know, we haven't got much to lose. It was in a field for 20 years. Probably more. But if we put it into the back plane, we can at least use the main power switch to switch it on.
Yeah.
That's worth a
Are you
shot.
going to send it with the two regulator cards in there immediately?
Hell yeah. I mean, if we're sending it hard, man. I'm pretty sure
Ready
that
for
we
the
can.
smoke show.
Yeah. I'm pretty sure what'll happen is it'll just shut itself down immediately. If I can even remember which regulator card goes where.
Yeah.
They both
Seems
have
like
keys.
they do have fuses on all of the outputs of the transformer, so that's good.
Yeah, we got a bunch of fuses in this thing.
Avery's not here tonight, so just let me take the opportunity to say dim bulb tester.
I'm not sure that would do anything on this.
No, it wouldn't, but I have. You have to mention it at least once.
So all of this fancy, like, actual card stuff is not even going to be within 20 feet of that thing. Because we can afford to blow up a lot of stuff, but those cards we can't.
Yeah.
Power supplies. I'm not married to a power supply, so I'm willing to
I
get
guess
funky.
The difference here is I really always try to keep my hardware like fully original, including power supplies, including like original discs. So.
Oh no, I absolutely do that with the large majority. I mean, I went through the efforts of like bringing up the G15 in completely original state, and I'm going to go through the effort of recoding the drum so we can continue to use a drum on another G15. Like, that is a big deal for me. But also, if something's been left in a field for 20 years, it's now a toy. And I like playing with toys, so I'm not particularly married to this thing.
So we're not doing caster adapter plates?
No, God, no. No more caster adapter plates for me, man. I've already torn one glove. That's awesome.
Really looking forward to that drum recoding, by the way.
Yeah, that makes two of us. I have no idea how that's going to go.
Is there a good reason to put it in the chassis to do the initial power test?
So I can have the power switch.
Oh, well,
Yeah, remote sense as well. Like it
Yeah.
won't be able to regulate without the backplane.
Yeah,
I
but
was
there's...
I was just thinking if you want to apply at least power to the transformer, it might be safest to do it out of the chassis.
I mean, will the transformer actually get power even if everything else is shut off?
Yes, because there's a standby voltage generally.
There is. Yeah, let's see.
I mean, if the transformer will get a full 120 volts into it, regardless of whether the regulator cards are in it and whether it's in the chassis, we'll start there.
Correct. It will. There's a fuse and a switch on the input.
Oh,
a
then we're gonna
mains
start there then.
filter, Yeah, the fan and the transformer should just start.
Okay. I mean, the fan is outside because it was hyper gross. Also, the table is hyper gross now. Yeah. Yeah. I like
I'm
to be
sorry,
as
but
original as possible most of the time.
Yeah.
But you know, somebody clearly did not care about this, and the TI-980 is not necessarily the rarest or most special machine in this room. So we're just going to have a little bit of fun with this guy. And it's not going to hurt my feelings if we end up putting full meanwells on it.
It is
You gotta-
encouraging to see you deal with this grossness, because I mean, I've spent months dealing with things in similar conditions. And glad to
Yeah.
know I'm not the only one crazy enough.
Yeah, this
I
was...
mean, he kept the Dave kept the selenium in what was the first Bendix?
No, so I should have. I mean, they're still in there, but they're bypassed. And I only bypassed... I feel dumb. I hate this. I bypassed them because I didn't want to hear the YouTube comments about seleniums.
The fact that you left them physically in there, is enough
Yeah,
to start
I mean,
the YouTube going.
Yeah. But like, that's the only reason I bypassed him, is because I was just like, I can't emotionally deal with the BS that's going to come through the YouTube comments if they see that I have a selenium that's unbypassed. And then I bypassed them, and I got like 50 comments of people being like, why'd you bypass them? They were probably totally fine. And I just had a full-on breakdown. I was just like, what do you guys want, man?
Have you
Oh,
ever had mates
well.
filters blow up on you?
That fuse is no
I
good.
have. We had a deck, like the deck building blocks, the pre flip chip deck building block module power supply with a mains filter cap on it. Actually, no, a ferroresonant cap on it, and the voltage started to drop. So I was tweaking it because I, figured the caps are old. It's getting back to life, things like that. And then the voltage dropped off a cliff. And as I'm like investigating it, and I have my face in the thing, the cap exploded.
Yeah.
Jeez.
The line filter on my 750 tried to gas me.
Yeah.
All right, so we're going to have to replace F1. The fuse holder for it came apart. Like, fell apart in my hands, came apart.
Gonna send it, just bridge it.
I mean, I am tempted to do that. We can just plug them into each other. I think F1 is a slow blow as well. I'm not sure. Yeah, I mean, the fuse still looks good. The thing has clearly not been powered up in like several years. Oh, jeez. You know it's rough when plastic has rust on it.
Yeah, that's
Yeah. Well, if I'm going to bridge it, I would at least like to insulate it so it doesn't fall and short out on stuff. This is a classic case of do as I say, not as I do.
Yeah, to be fair, I suggested that because I know what you're doing, but it's definitely not good advice.
Oh no. And we would, I mean, if it works, we're not going to leave it bridged. And if it doesn't work, F1 that's not an input AC fuse, is it?
On the schematic I have in front of me, F5 would be the input AC fuse, 10 amps.
Yeah. That's not even on the back here. I don't know where F5
F1
is.
would be a 10 amp fuse on the output of the transformer,
Okay.
as well as F2.
15 amps on this guy, but yeah. If they're output fuses, then I'm less worried about them. We're going to have all sorts of other issues long before the output fuses come into play.
Yeah, they're transformer output fuses, not power supply output fuse.
Yeah, she'll be right. Oh, that is jank.
We're going full photonic induction tonight.
That's how you know it's getting good. Oh man, I might as well just remove those two. So there's a little AC cap that goes right across the AC, you know, the death caps, that has fully rusted through. One side of it has broken off completely. And so I've just got these like wonderful exposed mains AC stuff floating around. Yeah. Oh God, that is atrocious. It's a 0.0053 kilovolt cap. I don't know why they've got 3 kilovolt, but something in here is getting to the kilovolt range. All right. So I think this switch on the left is a battery on-off switch. This switch here is your primary circuit breaker. So we're going to flip that on. My laptop is going to have to go on battery here, but it's the other laptop, so I think it'll be all right for a little bit. If it turns off, it turns off. All right. Oh God, that is a crusty plug. Oh,
Make
that
sure
did
you
not
don't want to
sound
wear
great.
eye protection.
Oh, I'm getting very far away. I'm like, you guys are far, far closer than I am. I'm a solid
Don't forget
6.
to
I'm a solid 6 feet away.
I'm 125 miles away and I don't feel safe.
Yeah. All
I'm
right.
on the other side of the country, and I'm questioning whether I should back up.
All right. Contact.
You should move the PCBs. Move the PCBs.
Those are the regulator PCBs that go in there. I'm not too
Oh.
worried about those.
Oh, I couldn't see it behind the chat. Okay, good. All right,
Yeah. All right.
send it.
Yep. Well, something popped immediately. That was exciting.
Oh,
Yeah.
Oh,
I didn't see what it was. Did you guys see where it came from?
It looked like
Something
it was in the top.
Glowing and flying.
Input filter.
It was the input filter on the right hand side behind the terminal block. The little
Okay.
Well,
can.
it looked like it was coming from behind the input filter from the camera angle. Yeah, there.
I mean, the
Which you
input
should
filter
also
is
be able to bridge out.
Ooh, that was exciting.
I mean, at least the transformer seems like it's okay.
Well, I don't know. Did
The
input ever make
surface
it to the
level.
transformer?
Oh, that's a
I
fair
mean,
point.
That input switch looks like it's a breaker, and it didn't trip.
Yeah, the breaker didn't trip. So input filter, I think, is a solid guess. Anything on the other side of the transformer is going to be so low voltage, I don't think you'd get a big spark like that, right?
Well, if it's fully shorted, but it wasn't in that area. It was really like just behind the input filter.
Yeah. So what, an input filter should have infinite resistance across it, right? Or am I going to be also measuring the am I also going to be measuring the primary winding? Yeah, the
should
input
be
filter is showing infinite. Oh, wait, nope. 0.6 ohms.
It's going to be the winding.
0.5 ohms. Yeah, that might be the winding.
I threw the schematics for this part of the supply in the Discord channel.
Yeah,
It's
let me
the
look that up. I'm
upper-
curious where that input filter sits and how it's wired up. Does that doesn't show the input filter on it, does it?
No, it's
I
the
don't
one
see it.
above it. It's the over 20.
Oh, I gotcha, I
right
gotcha.
time zone.
I gotcha. Oh, it just shows it as a black box. Great.
It's
But I
clear
suppose
that-
it doesn't
that
really need. Yeah.
3 is the ground terminal. 1 and 2 are the input, live and neutral.
Yeah, so I'm trying to figure out what I can slice out of it to essentially remove it, or how to bridge it. Because we essentially just want to take pin 1 and connect it up to terminal block 1, and that would effectively remove the filter completely, right?
No, it would be
No,
Yeah.
no. We're also going to have
pin
to
1,
take,
terminal block 1. Yeah, and
and then terminal
pin-
block 3 needs to go to terminal block 5.
yeah, correct.
Yeah. So my terminal block doesn't look like that, which is
The
exciting.
maze filter should. Can you send a picture of what that assembly looks like from like the front, from the looking
Yeah.
from the transformer?
Yeah, I'll post it in there. Of all the things I was expecting to blow up, the filter was not on my list.
Like I said, the one in my vacs let out so much smoke. I was coughing for 2 days.
Yeah, I got 2 windows in close proximity. I was prepared just in case. All right.
Yeah, usually when these go, they keep working. So they let out a lot of smoke, but they don't trip the breaker. They don't go open circuit, so the machine keeps running.
Yeah, and that may be the case here. This one may have just gone open circuit, and then now we're fine. There we go. But I would like to excise it. Oh, Titian. Yeah, good catch, Titian. The F1 that I'm looking at to the chassis is the 15 amp, not the 10 amp that's on the 9-volt AC. But yeah, it's still, that's 35 DC rectified output, so I'm less concerned about that. There's no AC voltage going through that. Oh, Adam got a screen cap there.
I made a clip. You can probably see it on Twitch. I'm not sure how that's done, but I did create a clip.
I don't know. I don't know how to use Twitch. Well, I'm trying to figure out where that light's coming from, because it doesn't necessarily look like it's coming from the filter.
Me, it
It
looked
went
like
towards the filter. Here, I just uploaded it.
me. It looked like it was coming from the big lugs closer to the back plane.
Oh, those would be the diodes, which would make sense if the caps are short. It would be a diode going up. Yeah, wait. Can you look at the top stud mount diode? It looks blackened from here.
No, that's just a whole lot of rust that you're seeing.
Okay.
Oh man, I should have gotten the slow motion onto this thing. Yeah, I don't know if that's the filter. Looking at the clip there, I mean, it definitely looks like.
It definitely looks like it came from up front.
You mean up front, as in like where the PCB is, right?
Yeah, where the PCB and the big caps are.
Okay. Yeah. Yeah,
I think it did.
Kind of what I'm thinking.
Yes, it definitely did. It came from up front on the PCB.
Fire and brimstone, indeed. All right, so now we got to figure out what up there went exploding.
Well, there's a good chance those big caps need to be reformed.
Oh, there's a extreme chance that those big caps need to be reformed. All right, I guess we'll pull that board out.
Yeah, it really looks like it was that diode.
Yeah, in which case I need to desolder it anyways, so. Okay. If the diode is, well, whatever.
You could
We'll go ahead and pull
unscrew
that
it and
board
just put a diode tester on it.
up. Yeah. Unscrewing it might be easier said than done. I mean, the whole thing is extremely rusty and gross. Let's see what it does here. Let's see if I can find the right size wrench. All right, maybe one of these will fit. So I'm guessing that the plate of the diodes are where the other half of that diode goes, just like straight into that plate, which is kind of exciting.
Correct.
Sure, I can unscrew it, but that doesn't mean the diode's gonna let loose. I would have expected something else to trip before the diode went. Or I would have expected not a whole lot to move without the regulator boards in it. I mean, I was thinking that the diodes were on the other side of that regulator board for some reason.
I mean, assuming that part of the schematic matches this thing, because it does seem to be different revision, those diodes would be directly behind F1 and F2.
All right. I need bigger wrenches. The diodes have corroded themselves into place. 2 3/8. We'll take a 7/16.
Angle
Could
grinder?
Could the cases of the diodes be steel and that's an aluminum plate they're mounted to?
That's entirely possible. Oh, it's bigger than a 1/2 inch. Jesus. All right.
It's the old
9/16.
Yes,
It might be
5/8.
5/8. 5/8, I think, is a solid guess.
I always have trouble with 1/2 inch and 9/16. My eyeballs just aren't calibrated properly for them.
I mean, it's pretty close to a 17 mil. Growing up working on Japanese cars, I can spot a Japanese sized bolt at a glance. The 5/8 was too small.
I must say, I've dealt with these diodes, and I've never had to use American wrenches for them, so that would not surprise me.
All right, let's try 11/16.
Wait, Cully, did you mark that up or did you actually get that frame?
I actually got that frame.
Oh my god, I didn't get that at all.
Yeah, that was from the video. Whoever sent the clip and the thing, I was able to pull that out.
Oh yeah, that is
That was me.
definitely the diode, 100%.
Yeah, I was able to locate that frame and screen capture it.
Whoa, how did you get that frame? Wow, that is awesome.
Amazing.
Well, it's definitely the top diode.
It's not a great photo, but it like clearly shows a thing disintegrating.
That's not like AI enhanced and making shit up. That's like an actual.
No, no, not at all. That's the actual screenshot.
That's amazing.
That actually looks like a little bit of aluminum burning, honestly. That bright white with the trails.
It makes me wonder if the
It's
diode's
clear-
not what went, but the corrosion between the diode and the bottom plate.
You're the insulator.
Because the corrosion is out of this world.
It
You know,
might
eventually
just straight up
we'll have
welded
a-
itself.
Eventually, we'll have enough of these clips we can set them to the 1812 overture.
That's an unbelievable screen cap, man. That is awesome. Well done.
Here's a better one.
How are you getting that?
I just paused it at the right time. Just purely just hitting the pause.
That's
I'm gonna save the
unbelievable.
video and just freeze frame through it.
Oh, I opened it in VLC and now I see it. Yeah.
That's amazing. Oh man. Already most successful Twitch stream on the planet. All right, let's see if the
Heck yeah.
diode is dead or if we just burned through 20 years of corrosion.
Yes, that's my guess.
I think that could be the thumbnail for the VOD.
It will be. Oh man, I can't even get through the corrosion on the I can't even measure it because the corrosion where the solder joint is so ridiculous. I can't get through it. 0.49 volts in that direction. And nothing in that direction. The diode is still dioding, man. We didn't
What?
we didn't blow the diode. We just burned through 20 years of corrosion.
That's crazy.
Oh, you guys can't quite see that. There we go. Yeah, 0.49 volts.
He just cleared out the squib load.
Yeah. Yeah, that diode's fine, man. I don't think it, and it was definitely the upper diode. I don't think it was the lower diode.
Makes sense. I mean, if those capacitors are empty, then just charging them is going to be a pretty big current peak. So.
Well, and the current's trying to go through the most insane corrosion I've seen. We're gonna get some Scotch-Brite Scrubby on that. Clean those up. Yeah, I probably still should get that PCB out so that I can unscrew the caps and bring them up on the bench supply. All right, we had our fun. Let's do it right. If we didn't, not have our fun though, we wouldn't have seen a cool light show.
Hey, if you could have a non-destructive light show, that's awesome.
I mean, that went as good as we possibly could have hoped.
You got a whole nother diode to go there.
Yeah.
Well, and it also pointed out that you've got a corrosion issue with those diodes that they need to be pulled and cleaned.
Yeah.
not just the diodes. There's also that thyristor next to the plug with the wires, like next to the capacitors. It goes on the board. That will probably.
Oh
have the
yeah,
same
that
issue.
one's probably a little rough too. All right, I don't think we're going to be able to get the board fully out, unfortunately, unless I desolder the diodes, because they're soldered to the harness. I don't know if I can get to that one. I need a shorter screwdriver. Dang, that is a great screen cap, man. That's awesome. Take it easy, Philip. You probably already left a long time ago, but I've said it for posterity's sake. Yeah, you definitely were not meant to remove this board with the transformer in place, it feels like. Because there are 2 screws on the bottom that are almost completely 100% inaccessible. That's going to be a pain. Yeah, that's the one. Oh, wait. Oh, you can get to those from the outside. Oh, look at them. I stand corrected, TI. I take it all back. Oh, that's crunchy.
Steel screws and an aluminum chassis, I'm sure.
Oh, yeah. Nature was not kind to this thing. There we go. All right, let's see if I can get those. I can now rotate this up enough to get to the back of the caps. I do believe. And while I can unscrew the caps, oh, there we go. I'll get a picture of that for everybody. If I can find my phone.
You'll want a picture anyway for make sure you get the polarity correct, right?
Oh yeah, that's not a bad idea. So I've got since we're talking about caps here, I've got this idea percolating for a video. And I want to collaborate with both Mike and Shelby on it. And I want to do a deep dive into the capacitor plague. And I want to do that by getting some Sprague caps from the 1950s, cutting them open, draining the electrolyte out of it enough. I only need like a milliliter, but draining the electrolyte out of it and taking a spectra of it, and then doing the same for a capacitor plague cap, getting a spectra, and trying to compare the chemical composition differences and talk about like, man, oh, that's rough. Talk about, you know, why we think the capacitor plague was so brutal and why that mindset of just recap everything doesn't apply to, you know, specific eras of capacitors.
There will be significant differences between a 50s or 60s era electrolyte and something from the 80s, 90s, or 2000s. I think.
Oh,
Yeah.
absolutely. There's going to be huge differences.
Yeah, and you might be better off looking at like the 80s, early 90s, late 90s, early 2000s, late 2000s, because that'll bracket the whole era.
But also, but the point is that I want to be like, you know, just because it's an electrolytic capacitor doesn't mean it is subject to the capacitor plague, right? Like the one of the main reasons I want to do this is to prove that yes, there is a significant difference in electrolyte, and this type of electrolyte that was used in the 60s and 50s, or even up into the 70s, did not tend to break down like the electrolyte used in the 80s and 90s. And we have, you know, definitive proof that the come on now. We have definitive proof that the electrolyte is chemically this different between them, right? So
the thing is, what's happened to a lot of 80s electronics is leaking capacitors, not necessarily the capacitor plague. That has more to do with the sealing and you know, breakdown of things over time. Where the capacitor plague is like, isn't that like specifically the late 90s when that manufacturer stole the formula but didn't get all of it?
Late 90s, early zeros. Yeah.
Yeah. So that's what I was thinking, is that you really want to bracket that electrolyte. And there's good capacitors in that era, and there are bad capacitors in that era, depending on the manufacturer.
yeah. I just feel like I get so many comments from people that are just like, I would never trust any capacitor older than 2000. Just replace them all. And I'm like, that's not the right answer, man. You know, but at the moment that you try to be like, no, it's really far more complex than that, everybody immediately goes, well, it's whatever, I don't trust it. But nobody has like a legitimate reason why they wouldn't trust a capacitor from the 70s or the 60s even. It's always just like, well, I've had other capacitors go bad on me. And so like, I want to be like, listen, here is definitive proof that the physical construction is different, the electrolyte is different. They are different things.
Oops, sorry.
You can go ahead.
I was saying, like, the caps in all of my machines are original. I have never replaced a large electrolytic in anything.
But here's the thing, like, neither have I, but that's just anecdotal evidence, right? Which is exactly what they, I say they as if though they're the bad guy, but it's exactly what somebody who would recommend a shotgun replacement has. They have anecdotal evidence as well, right? But I just so happen to have some scientific equipment here that can take us from anecdotal to like something that, actually has a little bit of credibility to it, right? But it's just like, how do we approach it, right?
How about opening up a couple of these older caps, putting them in one of your machines, Bowman or the other one, and figuring out what's actually in there?
Yeah, that's kind of that's kind of what I was hinting at, going for. Cut open a cap, squeeze out the electrolyte into a cuvette, pass a bunch of IR through it, compare it, contrast it. Oh, come on, let go. And then, have... Oh, geez, that one does not want to let loose. All right, let's move over to you. I'm sorry, you were saying?
I do wonder if part the problem is that they power the capacitors up right away without trying to reform them, because that big one you had trouble getting loose there. They're also in the VAX I have. There it's known that machines that have sat for a long time, you really want to just slowly reform them, and then they'll work for decades more. But
yeah, I usually reform caps. I mean, if you watch today's, well, I don't, you're a patron, right? Yeah. So if you watch the video that I just posted up for the patrons, like I don't reform them like you're supposed to reform them, but I do put them on the bench supply and bring the caps up in the LGP slowly. Slowly for me. Yeah. Shelby would think that I was doing it at Mach speed, but And I almost always do that. I'll take a cap out and I'll put it on a bench supply and, bring it up slowly.
Yeah, so that's why I wonder, like, the people who don't do that and then have the caps fail on them, do they think it's capacitor plague while they should have just reformed it? That's my theory.
It's entirely possible. Let's see here. I'm going to mark this to outside.
Sorry that I'm walking in here a little late, but I can actually answer that one there because I was someone who did that with the 4-phase. I looked at the caps and said they look okay. I benched them and reformed them. They look okay. And then I used them, and as it turns out, 2 had actually failed and gone open, and another one had poor capacitance overall. And it ended up blowing my 5-volt regulator up because it was just far too much ripple for it to handle when it was loaded.
What kind of caps were they? Like, who was the manufacturer?
Manufacturers, they're right behind me, actually.
Is the what?
They're made by my Mallory.
Oh, Mallory caps. Okay.
Yeah, so like 45,000 microfarads at 15 volts. Like, what I found is that some of them, like, sure, there's the obvious Maraca ones where if you shake them, like, you can hear the dry electrolyte inside of them rattling around. Those are no good. But one of them I found internally was just open, even though it didn't make any rattling noises. So, like, you gave it a voltage, and then you took it off. You had no residual voltage. It was just dead.
That one is very corroded.
I'm worried you're just rotating the feed through the capacitor.
Yeah, I'm pretty sure that's what's happening, actually.
Yeah.
Let's at least get the other ones off here. This is an 18 volt, no, 22,000 15 volts.
Yeah, in my experience, caps from the 60s will be less reliable than 70s and 80s caps. But...
Really? I've never had any issues with caps from the 60s. I think I've had, no, like, actually come to think about it, every single cap on the G15, totally fine. LGP21, totally fine. HP 150A, the Bumblebee caps were bad. It depends on what caps we're talking about. Bumblebee caps were pretty much all totally pooched on the HP 150A, but all the electrolytics on any of the HP gear that I've had have all been totally fine.
Yeah.
Yeah, so my experience there with like 60 stuff's mostly old radios where you had the split capacitors, like the 2x50 microfarads, and those
The old
always fail.
paper capacitors were horrible.
Our straight 8 is fine. The straight 8 at the Rhode Island Computer Museum, the caps are okay. They're originals.
The oil-filled run capacitor on the Lytton, on the other hand.
Oh, F that, man. And actually, the Lytton had another cap fail on us. That was the one of the AC cap for the ferroresonant failed too. So whatever the Lytton used, but that's almost 70s. And actually, that one was 70s. I think the Lytton was started production in 1969, but that particular Lytton was like 71 or 72. So we can blame that one on disco. Oh, that's too big of a screwdriver. I have found that once you're up into the 70s and even up into the 80s, the Mallory stuff is a little less reliable than the Sprague stuff for whatever reason. I don't know.
By the way, don't you want to rest this thing on the capacitor now? Because you're flexing that PCB an awful lot.
I can't. It's soldered. I can't get it. I can't move it around. The wires are still soldered in. I don't know if either of
Maybe
these are
if
gonna.
you put a block of wood or something between the transformer and the cap, you could rest it on there.
She'll be right. I might be able to get low enough to get the cap onto the transformer. Yeah, there we go. Well, no, that didn't work well. I'm just making a whole boatload of noise.
All right,
There we go.
I'm gonna go to bed. Good luck. Good luck with this thing.
All right, man. Take it easy.
Excited to see you. Take it easy. Take care.
Thanks for the screenshots. Jeez. That one does not want to come loose. Well, the cap is probably fine. What happened is the steel bolt has fused itself to the aluminum post.
Yeah, but I mean, once you're done with this, you'll have damaged the cap so much.
Yeah. Yeah, I don't think I can break that steel bolt loose, actually, is the next issue. So we may just plug it into the DC supply while it's sitting here on the thing.
Reform it in place. Yeah.
Yeah. An in situ reformation.
I mean, I know people just reform the thing by slowly powering it up with a Variac, so.
Yeah, that's what we're gonna do. We're gonna see if we can do it without lighting things on fire. All right, let's get that bench supply out. I don't even know what that cap's good to. I'd hate to cram 30 volts down it when it's a 10-volt cap. It's a Sprague Powerlytic. Looks like 67,000 at 10 volts.
So that's probably the big boy on the 5-volt rail then.
Yeah, 67,000 is pretty big. All right, let me get a power cable for my bench supply here. All right. The new layout of the room means so much of my stuff is in the garage as opposed to in the room. So there's a lot of going in and out of doors. All right. I'm just making all sorts of noise. There it is. All right. We have a cap down. What is that one? That is a 49,050 DC. That's a big boy. All right. Let's go. You're my plus. Let's see if I can do this without shorting anything out here. Probably not. My minus, I could just clip onto almost anything on that massive minus plane, but I think I can actually get that to hook on. Plus, I may actually have to remove and clip onto the actual. Oh, I can't get through, can I? Oh, I can come. There we go. There we go. I'll get minus Yes, this is super janky. Well, it's sitting at 1.5 volts apparently.
That's a good sign.
There's 2.5. There's 3. It pulled almost 100 milliamps there for a second. And at 3.5 volts, it's pulling 30 milliamps continuously. But that's coming down. It's reforming itself.
Nice.
There's 20 milliamps. And then if I drop it back down again, it's slowly draining, but it's holding on to it. So it's not like shorted or anything.
I could bet the inrush on that was quite extreme.
Oh yeah. Yeah.
That's going to be the fireworks that we saw.
If I remember right from the schematic, that's a 30 amp 5 volt.
No,
rail.
this is oh yeah, potentially.
I mean, for the computer, yeah.
All right, there's 5 volts pulling 80 milliamps. Shelby would be having a conniption fit right now. He like sets a limit of like 3 milliamps or something like that on his reforming rig. It took a lot of convincing to convince Shelby to go up to 10 milliamps.
Yeah, so the inrush on that is significant enough that they put the secondary fuse for the transformer after the filter capacitor.
There's 6 volts up at 80 milliamps again. Dropping to 60, 50 milliamps, 40 milliamps. Yeah, it's reforming slowly.
You should only need to go to like 7.5 or 8 if it's on a 5 volt rail.
Yeah, well, and it's only a 10 volt cap, so I'm not going to push it to 10 volts. That's a recipe for danger. I think I'm going to go up to about 7.5, yeah. There's 7.1. 70 milliamps, 60 milliamps, 50 milliamps. I mean, ideally it would be 0. The LGP21 caps were instantly 0. The second that I stopped increasing the voltage, they just dropped to 0 milliamps. They were really good shape. Yeah, there's 7.5 volts, 7.6 volts. It's at 50, 40. So let's sit there for a second. 30 milliamps. Yeah, I mean, I think that's probably reformed enough for it to reform itself when we power it up. I mean, look at that. It's holding 6 volts. It's slowly dropping, but I mean, that's not bad at all. Yeah.
Yeah, it's really nice, despite the violence you put into the screw.
Yeah. Yeah, I was not kind to it. All right, let's get this this big boy up here. This is a 50 DC, so I'm not going to be able to get anywhere close to that. I can get up to 30. But it's 49,000 microfarad. Let me get a chair. I don't know why I'm doing this sitting on the ground. All right. Ooh, hey, there we go. There's 3 volts, 4 volts, 5 volts. I mean, this is nothing for this thing. There's 10 already at 0 milliamps. This one I think is in particularly healthy shape. There's 15, already at 0 milliamps. There's 20. Yeah, I think this one's totally fine. I mean, I'll take it all the way up to the max of this supply, which is 30 volts. $31. I think I can get to almost 32.
I mean, it's an input cap, so it's going to see a little more than that, probably.
Yeah, I can't get any higher, though. I mean, I'm maxed.
Ah.
Like, that's all that's all she'll do, Captain. Yeah, 31.6 volts or something like that. And it can't hold that stably. It seems to be kind of walking all over the place.
Well, it's only rated for 30, so.
No, this one's rated for 50. The power supply is only rated for 30. Yeah.
Yeah, it's a 0 to 30 volt, 0 to 10 amp supply, right?
Yeah. MS3010D is the part number for it. Yeah, that cap's fine. That's still holding some juice. Let's see here. These little guys are good up to 15. So we'll take them up to, say, 12?
Yeah, 12 should be good. Those might actually be the 15 and negative 15 if they're in a pair.
There are two of them. It seems strange that you would have a 15 volt cap on a 15 volt rail. Usually you overrate your caps.
These are these 22 something?
Yeah, 22,000.
Yeah, that's plus and minus 9.
There we go.
C1 and C2. These are the ones that are behind fuse 1 and fuse 2.
Yeah, there's 12 volts. Pulling about 10 milliamps. They've probably never seen more than 9 volts in their life. So we're probably in a new region where they're like, what are we doing up here? This doesn't make any sense. There we go. Yeah. We've got bigger problems than bad caps, it seems. All right, let's see how this guy goes. It's looking to be pretty much the exact same as that other one. I think all the caps are decently healthy.
Yeah, I think there's a big chance that the fireworks we saw was actually not necessarily a bad thing. It's just the rust evaporating.
Yeah, I think we were just getting through corrosion. Which is the best kind of fireworks to have. It's like self-repairing fireworks. These were 15 volt, right? Yeah. I was like, for a second there, I thought they were 10 volt, and I was like cranking it up to 12. I had a panic moment. Yeah, these things are totally fine. I might clean them up a little bit because they're gross. And now I need to figure out how to discharge them.
There's a bleeder resistor over them on the board.
Oh, there is?
Yeah, 1.8K for these.
Okay. So plugging them in will discharge them. Although there's a good chance that I will accidentally short them on something in the process of trying to plug them in. All right. think we're okay to start reassembly here.
Yeah, don't forget to unscrew the SCR and
Clean it.
or at least like
Yeah.
check if it's rusted.
Think that's going to be this guy right here. Might be you. Yep. Yeah, it's not great. I need to get some Scotch Brite stuff. All right. Sandpaper. There's our steel wool lead. I think that's where the Scotch Brite is at. Yeah, there we go. All right. There we go. Yeah, it's not super clean either. Yeah, it's getting there now. That SCR should be good. Let's see. My eye vision is not good enough to see what the first half of your name is, but the last half is enjoyer. No, we're trying to just get some juice into the transformer to see how the transformers are going to behave. And in the process, we created a wonderful little light show, which has sent us down this path of cleaning random stuff. The light show, if you're on the Discord, if you're not, you're going to have to check for a clip on Twitch. But on the Discord, there's the clip is posted there, as well as some screenshots of the light show. It was awesome. And the coolest thing I think I've ever done on Twitch. Made a really nice spark. But that wasn't anything actually exploding. It was just us burning through some corrosion. You can actually see the corrosion that we burned through here. Let me get a picture of that. So that's where the two diodes went through. The diodes are steel probably, and then but they're bolted into an aluminum plate. And yeah, not great. The dissimilar metals corroded pretty dramatically. And then that dramatic corrosion had just enough conductivity to light itself on fire. Yeah, sleepy developer, you missed the fireworks. They were earlier, but I'm sure there are more to come because there's a right way to bring up a power supply, and then there's the way that we're bringing up the power supply, which is by plugging it in and sending it. Because I am not in love with the power supply. I mean, it was left outside for like 20 years, so this is going to be noisy. I'm going to do a little bit of vacuuming. Apologies in advance. That's going to happen more than once, though. This side is equally as gross. So if it turns out that we can get some life out of this power supply, I think probably next week we'll start the process of doing it right. Today is mostly just a how dead is it? Because it looks very dead. And if it turns out that it is indeed very dead, we will start down the journey of replacing it with modern stuff. Because like I said, I'm not married to it. But if it seems like there's some life, we'll then do it right. All right, let's get some of these caps back in. Let's also clean up their contact points. Yeah, I need to get a bleeder resistor.
How do the traces look on the back of that board?
Terrible.
Yeah.
Everything looks terrible, man.
Nothing obviously broken though.
Yeah, sure. We'll go with that.
I mean, honestly, compared to some of the stuff I've got working again, the board didn't look that bad.
I mean, it definitely could be worse if we're being honest.
I mean, I think
Yeah, I've seen worse
you're
too.
very lucky that there's a thick, thin coating on there.
Oh, you guys are just getting an awesome shot of my super flat butt. Oh my gosh. This is like, you can see like in high definition how few leg exercises I do. Here we go. Now you guys can actually see what I'm doing. You got to speak up when all you're looking at is my butt, man. That's the most embarrassing one. Yeah, I mean, we'll see. Like, if there's enough life out of this thing to go, all right, let's order some parts for it. Then I'll place a couple order. I'll place an order for a couple of new axial caps, and we'll go through and start bringing up the regulator boards properly. And then maybe we'll go through on this guy and clean it up a little more properly. And I don't know what to do about that transformer other than just leave it alone. Okay, that's positive, you're positive. But in this case, this is going actually better than I had imagined it, despite the fireworks. and the one cap that refused to let go. There we go. Let's get these two guys over here. Let's see here. Positive is this way. For you, oh my S. What are you? Oh, you're one of the diodes. You're the two diodes. Somehow you guys got all sorts of bent and twisted up because I've rotated this thing probably 100 times. There we go. Yeah, and I think for the time being, I'm going to leave the mounting bolts out of these big caps, because if we do want to reuse this power supply, I think I'm going to probably take things apart again and try to clean off as much of the corrosion as we can. Yeah, I'm pretty sure this cap went that way. Ooh, should probably clean this side of the board here. Lots of corrosion and rust on the front side here. Oh, but it's not on the, that's on the mounting spots. That's the actual cap through right there and there. Did I mark you as out? I did. So you're gonna go like that. All right, let's get this big guy in. And I think we'll set this thing back in place before I tighten up those two remaining diodes. And we'll get, let's see, you.
Before you screw the board in, did you check if the connection for the thyristor was good?
Yeah, I pulled it out, cleaned it, tightened it back down.
Okay.
Yeah, it was not nearly as corroded as the two diodes. But it still did get a little bit of the Scotch-Brite treatment. This is
Did you see the reminder about one of the caps having positive to ground? Like,
I just put them back in the same orientation that they came out. Whatever positive went positive. They really kind of only fit one way since they've got the big Oh, you're talking about these two little guys. But yeah, those went back in the same way. Those are very clearly marked on the backside of the PCB. So those were very easy to actually get back into the correct places. And then the two big boy caps, they've got those mounting metal brackets on them, so they can only fit in one way.
Yeah.
So everything should be back in the same orientation that it came out in at the very least. And given the state of things, I got no reason to think that anybody else in history has ever been in here. All right, let's rotate you around and get to the backside. Go. Grab these two. Naturally. I'll loosen these guys up. All right. I hate slotted screws. You can't really balance them on your driver to get them started.
I have a couple of flat screwdrivers that have these little clips that stick out to grab the screw.
That sounds like an engineer also hated flathead screws and engineered a solution to it.
Basically, yeah. Yeah, it's
He's like, I hate this, so I'm gonna make something that makes me hate it less.
when you've got to get a slotted screw down into something, they're kind of invaluable.
Yeah. Like with a good, I mean, if they're not stainless, with a good Phillips, you can get a magnetic head on them, and you can really snake a Phillips in there. But you just can't do that with slotted.
I mean, Phillips screws suck too, like because they cam out all the time and they're so easy to strip.
Well, that's why you got to get the JIS standard Phillips, and then the proper JIS. Those are really good.
Are those Phillips, or aren't those more like Posi-Drive than Phillips?
Oh, I don't know what they're plus, whatever you want to classify them as.
Yeah,
but the JIS standard is great.
Yeah, they're
JIS should be Posi-Drive compatible. Sorry, no, Phillips. Said it exactly the wrong way around.
Because yeah, I thought the JIS ones were not designed to cam out, whereas Phillips are.
No, Posi is not designed to cam out, but
yeah,
I don't know about over in the US, but here a lot of screws are Posi-Drive, like wood screws, etc., just used in normal carpentry. And lots of devices, especially those made in the US and Japan, have Phillips-like screws, and people use Posi-Drive drivers on them, and that immediately ruins them. So if you always use the right kind of driver, it's not nearly as terrible as most people think.
Well, if you get a JIS driver on a JIS screw, it's like almost as good as like a wrench on a hex nut. Man, they just lock in.
Yep.
I'm a big fan of Robertson's.
Of what?
Robertson's square drive.
I don't know what those are. You're just like a square.
Let me guess, you're Canadian?
No, Charles
Yeah,
is.
it just uses a square driver.
Yeah.
Oh, okay.
Yeah, they're pretty decent.
I use Torx wherever I can.
Yeah, those are good too.
I don't know. I got a problem with Torx in that if you drag a Torx across something, you can get a bunch of gunk stuck inside of the Torx head. And then your driver will not fit in there, and you got to get in there with a pick to clear it out.
Phillips can do that too, though.
Yeah, Phillips can do that, and Flathead can also do that. But a standard hex bolt, like a 10 millimeter, whatever, right, will not do that. I swear that fit on there. Yeah, it does. Our dog. So we have cows on the property, and the cows, we've had 2 new baby calves born in like the past 2 days, 3 days, essentially. And I don't know what it is, but our dog loves baby calf poop. She will go find baby calf poop and roll around in it. And it is disgusting. So we had to give the dog an impromptu bath today. All right, so let's flip the power switch on it and see if we get some more fireworks. You guys are gonna get nice and up close this time. And I'm gonna use the camera as a shield.
Don't forget the high-speed mode you mentioned.
That camera's inside. All right. Well, that was uneventful in the good kind of way. Nothing happened. So I think we're all right.
Time to measure voltages.
Yep.
Well, where can I measure voltages at? I mean, I don't really have
I
any
think
test
the edge
points.
connectors. The edge connectors should be an easy thing to look at.
Oh, the 2 on the top?
Yeah, let me. Or actually, the. Oh wait, I lost the schematics.
Because I can't get to the backside of the PCB, so I can't check across the caps.
Okay, can you measure between the outermost 2 pins on the top connector? And I think it's gonna be the wait, no, it's not gonna be on the left. It's gonna be the 2 rightmost pins on the top connector should be across that 50 volt 45K cap.
So you're talking pin 79 and 80?
Here they are labeled as 77 and 79. So the top one is one shorter.
I gotcha.
Yeah.
You're not talking top and bottom row. You're talking top right, and then second from the top right.
Top and bottom row are mostly bust through.
Okay, I gotcha.
Yeah. So those should be the plus 35 unregulated rail.
Okay.
So it should be the leftmost one should be plus 35, and then the one next to that, the corresponding ground.
Probably going to get it as a negative voltage here, but
Actually, there's a bunch of them, so that's going to be the big plane below it as well. I would assume it's going to be one of the two halves.
all right, that was a big 0, 0. .16 volts. It's unloaded, so that's not super surprising. So we got 41 volts there.
Yep.
I say we start plugging stuff in. Just go ham.
You want to clean the obvious corrosion off of there before you put in those circuit cards?
I mean, the obvious corrosion is pretty ubiquitous.
Well, that one leaky cap too.
You might want to replace those two caps that have definitely leaked.
Yeah, the one in the middle of the board there.
There's this one
maybe check
and
for
this one.
shorts. Yeah, you know, might want to check for shorts.
Those have definitely gone. Although I think all of the caps have leaked. So they would all need to be replaced?
Yeah, this may not be a bad idea.
Yeah, I think probably these 6 here need to go. They're all in rough shape.
Interestingly, the corrosion is on the side away from the seal, which I would not expect if they actually leaked.
I mean,
Negative terminal.
Say we just plug it in and see what happens.
I don't expect it to do much without the CPU backplane.
Well, yeah, say we plug it into the backplane and then see what happens. I mean,
No, you'll need the front panel as well.
I'll need the what?
Front panel for the power switch.
The power switch is not on the front panel. The power switch is a separate thing off to the side of the front panel.
Oh, that's right.
Yeah.
My concern is that there's quite a few transistors on there. Are there any of them that are unique enough they'd be hard to replace?
I don't think so. 2N3055s.
Yeah, on the schematics, I'm seeing a whole lot of 2N2222s. 2907.
Yeah, it all looks like jelly bean stuff, man.
930, 2219.
Okay. Just worried if there's anything that's period in there that's hard to replace.
So there's
Bad
one or
cows.
two op amps.
Yeah, should be all right. I mean, what are we doing if we're not having fun, right?
Yeah.
See, this guy's got some 2N3502s and some big diode guys here.
The ICs are all 74 series, LM339, LM311, nothing scary.
Yeah, it's all just run-of-the-mill stuff. 2N3740s, one of those definitely looks dead already, so I'm not too worried about. Oh, that one is definitely shot. I mean, I can see through the metal casing.
Uh-oh.
I'll get a picture of that. Oh yeah, no, this one's very bad.
Those caps don't look too healthy either.
Oh yeah, no, the caps are not great. But this guy, whoo, that's the one that's not going to work the first.
Q17, I think.
Q16. Close.
Jeez.
Yeah, Q16 is certainly no good.
16, 5302.
So much for the gold plating.
Hey, there's some
that's
gold
just
colored
flesh
in
wood.
there. I see a little bit of gold in there mixed in with the brown and the orange. Yeah, I think that one might be bad.
That is actually one of the main switching transistors, because believe it or not, the 5-volt part is a switch mode power supply.
Oh, fancy. Yeah, so we're not going to get any 5-volt out of it. And that switching transistor will probably just burn itself up and not even emit smoke. So that absolutely has to get replaced. There's a bunch of caps that we probably need to order parts for. But I'm still kind of tempted to plug it in and ship it and see what happens.
Send it.
Tune for maximum smoke.
I don't even think it'll smoke. I just don't think it'll start up at all.
I wouldn't be averse to seeing a light emitting transistor.
Yeah.
They all are, though.
I mean, everything's a smoke machine if you operate it wrong enough.
Does make me think of this demo I saw at the European Space Agency Open Day here once, where they actually forward biased a bunch of solar panels, and you could see where there were defects because they would start glowing red, but it wasn't actually getting hot. It was just the thing operating as a like IR to reddish LED.
That's a smart way to do it. I like that. Man, it's not even midnight. It's not even midnight. We've already threatened to light stuff on fire twice. This is going great.
Before you put that meter away, it might be a good idea to just check your shorts on the outputs.
I don't know where the outputs are. That's the problem.
Well, on the transistors, let's see, emitter on Q16.
If there's a short, it'll clear itself.
It is a beefy supply, that's for sure.
Yeah. I mean, if there's a short, that's a problem that solves itself.
Yeah, fail to open.
Yeah. That's why they call it a fail safe, right? It safely goes to open.
If the crowbar circuits work properly,
nothing will happen. That's what I'm expecting.
If the crowbar circuits malfunction, oh boy. Actually, crowbars usually fail. On me, have usually failed to make the power supply stop working.
Remember that Curious Mark video where he blew up like half that HP computer because the power supply didn't have a crowbar?
Yeah, that was fun. That one took a lot of effort to get back to life.
So it seems like there's some resistors on the remote sense, so even if that's not bridged, it should still work.
When your computer leaves droppings on your workbench.
Yeah.
You're braver around us than I am.
So I've got a key switch that just says lock and unlock, but it's actually a wired switch. I'm guessing that's my power.
That's what I'm remembering.
Okay, because the actual front panel doesn't have a switch on it that says power or anything.
Titian in chat mentions that the 35 volt DC that feeds the 5 volt switcher has no fuse.
Dope.
So,
so that'll get real exciting
that is
real
not
fast.
Right. Not right. That had a fuse and we removed it, right?
Yeah, it no longer has a fuse.
That's the most empty 980 chassis I've ever seen.
Yeah, it took a lot of effort to get it to that point. And that's because it was so disgusting and had to get to that point to get cleaned. And it's still so disgusting after like 3 hours with the hose that I'm wearing nitrile gloves. This thing is atrocious. It is a crime against computing.
That doesn't have the IO expansion, does it?
No, it's got a short little backplane in here that's 1, 2, 3, 4, 5, 6, 7 slots.
Right, but not all of those are IO. There's DMA and other stuff that goes towards the front.
Yeah, you've got 2, the APP, DMA, and then you've got 5 IO slots.
Yeah. Well, there's an extension that goes in there as well.
All right, so the key is currently at unlock, which kind of implies that it's on.
Yeah.
Which is good. I didn't really feel like having to pick it.
This is a 2-phase buck converter for the 5 volts.
And I am going to get some distance on this thing.
So even if that transistor, if it feels open, you might still get output at half the current capacity because it's one of 2 phases.
Okay. So you guys are going to watch up close. And I'm going to watch. I'm going to employ my best safety squints, and I'm going to watch from a pretty big distance.
So we're looking for light emitting resistors.
Yeah. Really, nothing in there should emit light. If you see any light at all, that is bad. I'm trying to get an angle where you guys can see both. There we go. All right. And I'm actually going to watch the video as opposed to the actual thing because I'm going to be far enough away that the video might be clearer. All right. Contact. Nothing happened.
No.
Which I suppose is good.
But it hasn't actually powered up the full supply yet, just the 5 volt standby and something, right?
Well, the little switch on the front should be on. But we don't have a power LED or anything. But that could be because we either don't know how to turn it on or because it turned itself off because so much stuff is in unhealthy shape. So let's try, oh man, where are my lockpicks at?
Okay. During the turn on sequence, all voltages except plus 5 volt main come up as soon as AC power is up. An on delay signal prevents 5 volt main from coming up. When the on delay minus signal goes high, the 60 kHz clock is present and M reset is low. 5 volt ref is enabled and starts to ramp up. The 5 volt ref continues to ramp up to 5 volt unless an overload occurs.
So the overload probably occurred.
A bit more. But yeah, if you want to go about it like scientifically, I would look if that 60 kHz clock signal is present on the power supply.
Well, the first step I'm going to do is try changing the key switch from lock to, or from unlock to lock. If I can find my lock picks. I don't know where they are. Come on. They're not where they should have been. It's going to be awfully hard to do this without a key or a lock. Yeah, so I don't know if lock or unlock is on, because it doesn't say on or off like, you know, it should, which would be the smart way of doing it. And I have a full lockpick set. And I could tell you exactly where it is in the old room layout. But in the new room layout, I don't know where I put it. I don't remember.
I'm starting to wonder if it's even soft switch at all.
Well, that's not a very soft switch. I mean, there's some chunky wires that go to that thing. Oh, I bet you they're in the drawer over here. Don't mind me just trying to find a lockpick set. Because that's what normal people have hanging around, right? No. It's not in any of the drawers that would make sense for it to be in. Oh, yep, nope. Yahtzee. There it is. All right. This is the lock-picking Usagi. We're going to try and pick this lock. And hopefully my webcam will figure out what focus means.
That looks just like the lock on a Harris H100 computer.
Yeah, it almost, like, I can't tell where the tumblers are going to be. I'm betting that they're on the top, but...
If I remember right, it's a double-sided key.
Oh, well, that's
going
going
to
to
be
suck.
wafers, not tumblers.
If it's double-sided, it's going to be a little harder to pick.
Yeah, you'll have to alternate top and bottom if it's tumblers on both sides.
Yeah. Or wafers on both sides, or...
I really think that's just the lock unlock for the front panel.
To prevent it from being used? Well, then how do you
Well,
turn the thing on and
damper
off?
wafer.
Front panel on front panel enable.
So where's the power switch? Is it just purely in the back? You can't turn the thing on and off from the front? That doesn't seem right.
Not that old for stuff from this era.
I think every machine I have in here has a power switch on the front of it. I mean, the front panel itself certainly doesn't have anything on it that says power.
No.
I've got reset.
So the entire testing section doesn't mention anything about input signals, turning it off or on. Except for a little bit about bridging some resistors, but I think that's for running it without the main 5-volt card.
I'm thinking that you need to have the front panel in at least for the power supply to be enabled.
Why? What would the front panel be sending to the power supply?
Jumpers and such.
No, I really don't think that's gonna be the case.
I mean, I'm not going to plug this in there. I mean, I can appreciate that that might be the case, but those boards are the most valuable part of this whole shebang.
Right. Yeah, don't.
I mean, it could just be that, like, it's not powering on because, you know, lots of things are broken in the power supply.
Yeah, so it really should just be powering on. And yeah, because all of those control signal-ish things are outputs. And there's one for resetting the SCR, but that's only for it to keep state if the memory was lost or not, if you have battery backup.
Okay, so we're thinking that it's not coming up because there's enough stuff on the power supply broken that it's going, hey, let's not power up.
How do you know it's not coming up?
Well, the power light on the front doesn't come on and I can't hear anything. But I don't know, it might be coming up. How would we check?
So let's see. So I'm checking what they say for testing it right now.
I mean, I got a lot of pins on the back here that I could check. God, there's still like.
So they say so there's this
stuff in this thing.
AC. So I don't think it needs to be in that on the backplane. They say reasons for 5-volt may not to come up would be line voltage low, which isn't the case. 35 volts low or missing, not the case because you measured 40 volts on there. Auxiliary or reference voltage missing. AC detect failure on delay failure, 60 kilohertz failure, reference enable failure, or logic failure.
That's a lot of potentials.
Yes, but a lot of them are should easily be testable from the back of the 5-volt reg card, which is the top card. So it should just be possible to probe them with the power supply sitting on the bench.
Okay. Yeah, let me dig some wildlife out of the backplane right quick. This is after like thorough, extensive cleaning. I took a brush to this backplane. So the topmost card is our 5-volt regulator card. And on the back side of that topmost card, we can check some stuff.
Yeah, just checking the topmost one is the one with the transistor on it, right? The one that was rusted?
Yeah, pretty sure.
Yeah, that should be the 5-volt reg. Let me zoom in on the schematics and send a screenshot of the pinout.
Now, should we check that outside of the backplane or still plugged into the backplane?
Still, well, outside of backplane on the system, I think. Yeah.
I mean, you mean like remove it from the back, remove the power supply from the backplane?
Yeah.
Okay. That's a heavy girl. Both my laptops are informing me that it's midnight by reconnecting to the printers. Don't know why they do that.
So
Is this
trying
something I'm
figure
going to
out-
need an oscilloscope for, or can I do it with the multimeter?
The logic multimeter, but the clock oscilloscope would be best.
All right.
Gonna send
Give me a second.
this on Discord, and then I'll open up the. So that's
Maybe I
still-
missed it, but what is that switch on the back?
Which one? There's like 2 or 3 switches on the back.
The one on the far left.
battery, right?
That's for the battery. Yeah.
Ah.
Yeah. All right. All right, let's get this 980 chassis out. It's really lightweight with nothing in it.
So I think a good place to start would be to check if 5 volts aux is present, because it seems like that's what powers the 60 kilohertz clock generator.
You tell me what to check and what to expect, and I will check it.
So there's a photo of the screenshot of the edge connector pinout.
Okay.
And
That's
that shows where
the...
5 aux is.
Oh, I got
but
you,
I think
yeah.
it might be easier to if I give you a component location to look at.
What if you can just give me a number?
So 5 aux would be 43, I think. The corresponding ground would be 49 through 51 LC.
Gotcha.
Local common, I guess.
So let me mark that. Let me find. There's 79.1. So 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, 37, 39, 41, 43. You said 43?
43 is wrong.
43, 44. Yeah.
43. Okay. What's 45?
be
Because
5.
it's chunky as well.
45 is 5-volt main.
Okay. And then 49 and 51 you said was the corresponding ground.
Yeah, 49, 50, 51, 52 is the corresponding ground.
Okay, I can check those.
That should be a block of 4 pins connected in a square.
Yep.
Now 45 should be 21.5 aux.
Okay.
45.
That's 5.017 volts.
Okay, and then I'd say immediately just measure the 21.5, which should be right next to it, like towards the ground.
Give me numbers.
That is 45.
45.
45 with ground on what?
Ground on the same pins, 49,
Okay.
50, 51. Yeah.
That is 21.6.
Okay.
Ooh.
Well, it should be 21.5, so I think that's okay.
Yeah.
Okay, so it's getting its power supplies. I don't know if the 5 volt rev should be present already, but that would be the next one over, so that would be 47, immediately next to the ground. And that should be 5 volts, but it might not yet be present, because I think there's some logic involved in that one.
4.988. 4.989. Yeah, that one's
Okay.
present and close enough to call good.
Yeah, that should be the main 5-volt reference. Okay, good. So the thing's getting power. Then I guess the next thing to check would be the clock signal that is generating on that card.
Okay. That's going to require a
It's
scope.
not on the. It's not on the connector. The ground would still be the same pins that you were just using as ground. And U68 is an AND gate somewhere on the thing. Let me see. Because they're using an AND gate as a clock buffer, so I'm thinking that might be an easy chip to probe on.
I can't get to any chips. Well, I can get to the backside of chips, but I don't know what chips
Yeah,
they
exactly. So I'm figuring out where it should be. Because there's a component finder here.
That ground, is it shared with an easier place that I can clip onto?
It goes to a lot of places.
I mean, is it like the universal ground plane ground?
I am not quite sure. There's not a board layout here. There's just like component finder. But yeah, it goes pretty much everywhere. So if there's any logic chips, it would be their ground as well.
Okay, so I can use a logic. So the logic chip that we're going to probe for the signal, I can also use that for the ground.
So U6B is gonna be.
Hang on a sec.
The I'm just gonna send the component finder. Second, screenshot made. Now just to paste it.
So
Okay, I just posted a component finder. So U6 is gonna. Yeah.
I don't get U's, I get Z's. That's a 7409.
7409. Let's see what is a 7409.
Open collector, it looks like.
Yeah. Being very clumsy with my computer because it's 6 in the morning. Let's see. Yeah, that would be open collector and. Could that be correct?
Sure.
Then you want on U6, you want pin 6. That should be the V66 kilohertz clock.
And then pin 7 is going to be right next to it, which is ground.
Yeah.
Yeah.
Okay.
So 4 and 5 are the inputs, by the way. That should also be the clock, but, inverted. It's a very simple circuit, so I can almost, I don't see this failing.
Yeah, ground is going to be a difficult thing here. There's not a great place for me to clip onto a ground. All right, let's get this thing back in. Let's fire you up. I'm gonna have to do this with 2 hands.
Fortunately, it's all low voltage.
So lick it is what you're saying, right?
Not exactly.
Things are getting spicy on late night Usagi over here. All right, Keysight. You cost more than everything in the room combined. That's not true, but is this going to be like this 0 to 5 volt type of thing?
Yeah. Yeah, just plain old TTL.
Okay. And
All of the logic on this card is that.
let's all right. Let's see if I can do this. If I can get you to there and there, that should give us something. Okay, so I can do that by hand. So we'll come. Ooh. That time it sounded a little spicy on the power up.
It tripped the breaker.
No. I've been turning the breaker on and off.
Oh, okay.
Yeah, I think I was just a little slow on the breaker, and I heard a spark inside the breaker.
Ah. Yeah, the video delay makes it hard to.
Yeah. Well, pin 6 is totally dead. Pin 4 and 5 are at like 1.5 volts.
So there's not supposed to be any inhibit there.
So that makes me wonder if we lost. Nope, that one's still at 5 volts. That one's still at 20-something volts. And that one's still at 5 volts. So we still have our reference and all of our other voltages. We just don't have our kilohertz.
This really should just depend on the 5-volt aux, which we know is there.
Yeah, but you said pins 4 and 5 were the inputs, right?
Yeah.
Yeah, those are at like 1.5 volts each.
That flip-flop's not flopping.
Well, 1.5 volts is not a good input. Pin 3 is going 8.
It could be a different provision.
Yeah, I know, but pin 3 is active, so there's something going on. Pin 3 is very active.
So we know that some parts of the design are different, so this might be like a different version of the board, slightly different pinouts. But yeah, I posted the schematic of this of the clock generator.
Okay. You're looking at, oh yeah, U6 pins 4 and 5 tied together. On this board, well, if they're tied together, they're not tied together on the backside at least. So
U11 and 12 are not flopping.
Hang on.
That's the problem.
Let's figure out what's going on fully here.
I mean, if it's safer for you or easier to work with, you might just be able to put a bench supply on LC and 5 aux.
Yep.
I mean, we have our 5 aux. We checked that.
Yeah, fair. I was just thinking it might be easier to put the board right side up on the bench.
Oh, you were talking about troubleshooting it not within the thing. I gotcha. No, well, hang on. I'm not fully convinced that we're not also looking at a revision difference here.
Yeah, that might very well be it.
Let's slow down and walk through this a little more methodically. Where, just to double check, where is pins 1 and 2 of that same U6? Are they supposed to be tied together as well?
1 and 2 are not supposed to be tied together.
Ooh, that made a fun noise. I shut it off and it went click, 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 click. Like something was spinning down. Well, I can clearly see that on U6 here, pin 1 and 2 are tied together. I mean, I'll pop the board out and double check.
Can you trace where pin 3 is going to? The output?
Well, pin 3 was very active. Looks like that might have been a 60 kilohertz signal. Yeah, here, let me slide this whole thing out. Double check that I'm on the right IC first of all.
Can you send some photos of the back of the board and the front of the board?
Yeah. It's also not called U6, by the way. It's called Z6.
Interesting.
Fun stuff.
Do you know if this is a if this is the A or B model of the computer?
This is
It's the
A.
Yeah.
Oh, it
that
is
would
an
explain
A?
it.
Yeah, it's a 980A.
We only have schematics for B.
Yeah.
Because there's 3 different versions: the non-A or B, A, and the B.
Yeah. Well, I mean, the front of the thing says 980A, so
Okay.
I'm going with 980A. So on the pictures that I just posted, if you look on the back, I've got pins 6 and 7 marked. And then if you count up from there, you can see that pins 1 and 2 are tied together. Pin 3 looks like it cuts up. Pin 3, which would be the output, it cuts up to, looks like probably a pull-up. Yeah, pull-up.
Yeah. Something tells me that pair of transistors and capacitors there is going to be your multivibrator, like below the middle IC, Q11, Q12.
Yeah, 2N2222s.
Yeah, but the layout looks very much like what you would expect for that circuit.
Yeah.
I don't see. Oh, I got you. Q11 and Q12 up there, yeah.
Yeah, and they're also Q11 and Q12 on the schematics.
So the question is where do pin 1 and 2 on this thing go? They go right up to that region. So I think pin 3 is probably our 60 kilohertz output.
Okay.
I mean, what else on here should be vibrating at that speed? Nothing, right?
Wait a second. The ones you've marked with Sharpie?
Yeah.
That's the one you were talking about? That's not... No, wait. Am I...
That's Z6. It's marked as Z6. Okay, I'm pretty sure I've got 1, 2, 3, 4, 5, 6, 7 correct on that. I mean, I checked 5 times. It is midnight, though, so I could be wrong.
So, interestingly, on the component finder, where it's called U6, the one that's labeled Z4 on your board, I think, yeah, the labeling is different, but it is... Z6 is the only 7409, so it is the correct chip.
All right, so let's see.
So they definitely relayed out that part.
61.34 kilohertz is what pin 3 is coming out at.
Okay, so we got clock.
I mean, there's nothing else on here that should be oscillating at 61 kilohertz, right?
No, not really.
That's the clock.
That's a very nice square wave as well.
Yeah, I mean, that looks really nice.
Okay. Then there's a few control signals. There is on delay, which should come on after a bit to allow the power supply to turn on. Kind of like a slow start thing. Now the problem is that's also not on the connector.
Great.
Trying to see if there's any like obvious point that you would find it on. It's supposed to be on U2. On pin 3 of U2. And U2 is a flip-flop, so that it shouldn't be as easy for them to mix the things around.
All right, pin 3 of Z2. That is Z2 on this one is a 74 double aught. So 7400.
Yeah, that's not correct. It should be a 74121.
74121. That's going to be Z3.
Yeah. There should only be one of them, so that should be a pretty safe bet.
Yeah, but there's probably multiple flip-flops in that thing, right?
No, it's all flip-flop, I think. It's time delay.
Oh, okay. So pin 3 is the output no matter what, right?
It's an input.
Oh, an input.
It's labeled A2 here. I'm gonna look up the chip real quick because
I mean
it's got a RC time delay on it.
Tied together.
Which ones? 3 and 4
Pins
tied
3
together?
and 4 are tied together, yeah.
That's not what I'm seeing here. But it has 2 units, so let me see what the other unit's doing.
Yeah, there is only one
used at all.
74121.
All right, Dave. I have actual ranch work to do in a few hours, so I'm going to take off. Best of
All right,
luck.
man. Take it easy.
So interestingly, I don't immediately see the B unit of that chip used anywhere. Which might very well mean that they just tied its inputs together.
Quick interruption. Endora Fox just gifted a bunch of subs.
What? Endora Fox? You legend. What are you doing? I was looking away. Thank you so much, man. That's awesome. 10 tier 1s. That is excellent. Thank you, sir. That is wonderful.
Okay, no, this thing definitely only has 1 unit. You're saying 3 and 4 tied together?
Yes.
On the 121? Okay, then that part of the design is different, but it is the only time delay chip that's here.
Yeah. It's also tied to Z1, which is a 7403. So an output from Z1, which also goes off to a resistor and some other places. Looks like maybe a transistor too.
So supposedly 6 from that thing, pin 6, should go to 4142 on the connector.
Yeah. Yeah,
which
so
would
pin
be signal
6,
P off.
pin 6 from the 7403 does go to pins 3 and 4 of the 74121.
It's just odd because so it would make the logic very different between the two, which would be a problem for troubleshooting.
I mean, I can check what the input to I can check what pin 3 of the 74121 is supposed to, it is. What's it supposed to be?
Input. I have the data sheet here.
I mean, no, like what values am I expecting on it if it were operating like you were expecting it to?
Not so much a value as a signal changing when the thing turns on.
Okay.
So I'm just posting the excerpt from the schematic here. So I don't know what the bias signal is, but the other pin that's not supposed to be tied together was supposed to be the time delay for starting. So on delay.
Okay. I really need to find a place to actually clip my ground onto. That's a different ground. It's got to be there. Huh. I don't have enough hands. I'm gonna have to get funky. All right, let's see if I can get some ground action going on here. It's not great, but
Just checked archive, and there's nothing for the 980A power supply.
all right. So you're expecting this to what? Go high and then low, go low and then high?
The input, not sure. P off should be. I'm trying to find this. Yeah, the input should go high 8 to 18 milliseconds after all reg up minus goes low. But again, this logic is just literally different here.
All right, well, we'll see if it goes high at all.
Interestingly, I found some stuff that seems to suggest that the LED on the front panel might have to be off until you hit the reset switch, because apparently it indicates if the memory lost power or not.
Oh, okay.
If I'm interpreting this correctly.
I mean, is there a way that we could just check to see if logic voltages are present on the backplane?
Well, I mean, even on this card, it's going to be the output there. So there's a whole bunch of pins bussed together. And that should be the 5-volt output. Let me...
But would that 5-volt be active with this thing not plugged into the backplane?
It should be, yeah.
Okay.
The filter for it is on the power supply backplane. So, yeah, it's gonna be alternating like vertical pairs of pins from, so say 5 and 7 would be ground and 5. So it's that side of it. It should look like a big fork of things connected together.
Yeah, so let's see here. 1, 3, 5, 7, 11, 15, 17. Those are all bussed together continually. Would that be the ground or would that be the plus?
Wait, you're saying 1 is also bussed together?
No. Let's see here. 1, 3, 5.
Because 1 should be sense ground, 3 should be 5-volt sense, and then okay, let me work my way through this mess of connecting dots.
Yeah, no, what I'm saying is that I can see on here.
So 7 is supposed to be the first 5, and 5 is supposed to be the first ground.
Okay, but 7 and 11 and 15 and 17
19, 23.
Yeah, those are all tied together.
Yeah.
And
not
that's
17 though. 17 should be the other ones.
Right. Yes.
Yeah. Should be alternating ground at 5.
Yeah, they're alternating. So 7 is ground or plus 5?
7 is plus 5. 5
and
is
then
ground.
5 is ground, which would make 9 also ground?
Correct.
Okay. I'm just making sure that I understand what I'm looking at here. All right. I mean, I can check those. But we're honestly, we're not expecting this to be present because we're expecting it to be broken,
I
right?
mean, yeah. I mean,
Oh, we got
but if
up
it's all broken-
to 2.4 volts, 2.6, 2.7, 2.8, 3. It's trying. 3.3 volts. It feels like
So
it's slowly charging up that cap.
suspiciously, the reference input that is actually used is called 5-volt ref ramp. So it might actually be slow ramping its power supply.
Well, it's going very slow then because it's kind of stopped at 3.56.
It is a switcher and there is not a lot of load on it, so
Well, there is 0 load on it.
oh, some resistors here and there.
Yeah, it
Power
stopped at
supplies,
3.57. That's all she's got.
Just seeing if there's a minimum load for that rail specified.
We got Dora Fox. We got 69 viewers. Nice.
Don't immediately see them listing a minimum current on the 5-volt main.
Yep, that's all she's got. It's 3.57. I mean, a large amount of this power supply is actually functional, which I am shocked by. I can actually hear the switch mode stop switching when I power it off.
That's amazing.
I mean, we might be able to replace a few components, clean this thing up, and actually send it, use it.
Do you have an electronic load?
I have a 0.5 ohm resistor. That might be a little aggressive.
It's gonna give 10 amps.
It's like a
Should be
40 amp
fine. It's
supply,
still 30,
right?
yeah. 30, yeah.
Yeah.
Now how to connect it is the question.
Yeah, I was gonna say now we've got a bigger problem. Is I don't know where to hook it up to.
Yeah, because that kind of amperage, if you don't connect it to a place able to handle that kind of current, you might damage it.
Is that big capacitor across it?
That big
One of
capacitor
them,
is
yeah.
I
inaccessible.
know,
But yeah,
Yeah, there's not actually anything that I can even get some alligator clips onto, unfortunately. I mean, at this point, it sounds like we've confirmed that enough of it is working that I think it's actually worth continuing down this path of bringing this guy up correctly. You know, the transformer looks grody, but I think it's probably going to be fine, particularly as it dries out over the next week. So what I really need to do is just go through and make a list of parts that I need to order, and then I'll place that order tomorrow, and it'll be here ready to go by next week, and we can start swapping components out. Right? I mean, that seems like a logical path to me, right?
Sounds good.
Because there's definitely some parts on here that need to be replaced.
Before you clean everything up, I wonder what that 5-volt looks like on scope.
Oh, yeah. I mean, I can try that.
Oh, you
Good
just
point.
turned it off.
Unloaded, but still.
Yeah, I mean, it's suspicious that it gets stuck at 3 point whatever volts.
3.57. It's That's all she wrote.
So that ramp up is supposed to take what's it? 300 milliseconds. So.
Oh yeah, no, it took about 300 seconds.
Yeah.
Yeah.
I mean that's the ramp on the reference, not on the output per se, but yeah.
It's gonna be a little hard for me to catch a ground. Is that ground connected to chassis ground, I wonder?
Foam it out.
That's what I'm doing right now. 1, 3, 5. Just to double check, those two are connected together, right? Yes. How about you? No, 45 kilo ohms to chassis.
Oh,
That's fun. But how about to here? 21 ohms? That's not great either. How about you? 0. Okay, I've got two massive planes here that I can stab onto. That works. So I can just do that and that.
It would not surprise me if this limited voltage thing is because one of the two phases of the power supply is dead, because that's what that rusted transistor was.
Ooh, that went to negative voltage. I don't think I've got that backwards. Oh, not. No, I'm sure that's like down at like negative 49. I've got something wrong. That was showing negative 50 volts. What is that about? Negative 37 if I go there. So I was clearly just plugged into the wrong place. Trying to find a good way to get my ground probe onto here because I don't have a... All right, well, let's just do that. Hang on. Let me shut you off. Let me hook you onto this here. All right. So we're going to go from you to you. It's pretty flat, but it's still just stuck at 3.7 or 3.57. Yeah.
There's no switching ripple on there or anything.
Not that I can see.
Huh. That's funky.
I mean, if there is, it's like very high frequency. I mean, I'm at
it would be
20
at 60
microseconds.
kilohertz, right?
Well, I'm at 20 microseconds per division, and I don't see any obvious ripple. It's just stuck at 3.5 volts.
I wonder. It's gonna be tough to probe, but you've got that rusted transistor, right? Yeah. I wonder if you can see the switch drive at its base.
good point.
Yeah, I don't know which one is its base, and I don't know how to measure from ground to its base, though.
So the highest voltage pin on there should only be 35 volts, so you don't need to worry about blowing up your scope if you get it wrong.
Well, yeah, there's nothing in here high voltage enough to hurt the scope, but just trying to figure out what would be meaningful. Like where should I put my ground probe? So that transistor has 2 pins that come through on the center, and then the body is bolted to a really big fat trace.
Huh. So there should be 2 diodes around there. One is connected to the transistor.
Well, I don't know. potentially.
Yeah, I just posted
Yeah,
a
no.
picture of that sheet of the schematic. Should be 2 signal diodes, and then
What transistor number is that?
the rusted one is
216.
either 14 or 16, but the schematic random is identical. And that wire going down out of that block of the schematic, that should be the switch drive. And there's some level shifting magic going on around like Q20, Q15, but yeah.
Right. So I've got, but if I wanted to measure the base, where am I going to put my ground pin at? Is the next question. It's the big question that I've got.
Yeah, I'd say keep ground at the 5-volt ground.
All right, now things are getting interesting.
And that stream delay is annoying.
That's the price you pay for getting instant talking access.
Yeah.
All right, I got to get a little janky here, but I think I can do this. So if I'm looking at Q15 or 16 here, I can look at 3 things, right? Base, emitter, and collector, and we should see something on all 3 of those, right? Or I should
So
see a solid
collector should
35
be-
on one.
Yeah, that should be the collector. And then the emitter, you would expect to see pulsing, because that's the switching node of the buck converter.
All right. So what are you? You're at 3.5 volts. So that's probably our output. Oh, that one looks like it might be at 35.
But do
Yeah,
you see
that one's at
any pulsing at all?
almost 35. So U is the one that I need to look at. That one is also at 35.
Which
so two of them are at 35 plus, probably a little closer to 40. And one of them is at 3.5.
And the 3.5 one, is that pulsing at all?
No.
Huh.
That sounds like
okay.
it tried turning the transistor on, and it's just stuck trying to turn the transistor on.
Can you see if Q14, which should be the same type of transistor, with roughly the same circuitry around it, if that's doing anything?
Yep.
Now the thing is, if it thinks it's at voltage, you're also not going to see any switching.
That
because
is...
the 2 phases get ANDed with the comparator output. That's how it regulates.
Yeah, it's exactly the same.
So there's 2 options. Either it's not switching because it thinks it's already at 5 volts, or it's not switching for another reason. But then how did the capacitor get charged?
Is it?
Could it be that the capacitor just got charged via the resistors around those transistors, and that this is just what it does if it's not switching at all?
Yeah, I don't think I don't think it's switching. I think it's trying to turn on fully. And the transistors are just not moving any voltage through them. And so that they never turn off because the output voltage never gets high enough to turn the transistor off. Right? That's what the R36 feedback into the base is supposed to do, right?
A little rusty on this stuff, but it's supposed to be a switching converter, right? The transistor is supposed to be on or off.
Yeah, no, I've got that. And I think right now the transistor is supposed to be on. And it never, like, because, you know, if you're looking at Q14 or Q16, you've got R36 and R39 that go right back to the base of that, right?
Yeah.
So you've got the Q17. We'll just look at Q16 and Q17 because that's a little clearer. Well, I can hear the switch mode shutting off whenever I do that. That's fun. So you've got Q17 going on here. There's an output coming out of Q17 that's going straight to the base of...
I mean, that's just looks like a weird Darlington pair. No,
because you got a PNP and an NPN.
Oh yeah,
right?
no, I see.
So on the PNP, if the base is lower than the collector, then the transistor conducts. And so the voltage level on the base is going to be dependent upon where CR9 is going to, which is Q20. So whether Q20 is conducting or not is going to change what the base of Q17 looks like.
Can you see if Q20 or if you can find Q20 or Q15's collector? Because those should be switching. If it's trying to do anything, then those are going to be toggling, right? The clock signal is getting added in there.
Where's that clock signal coming in from? Oh, 60 kilohertz clock is coming in through
and then you got
U58.
So Phi 1 and Phi 2 are always supposed to be toggling.
And then Q20 and Q21 should, or Q15 and Q20 should be toggling the 2N1711s.
Yeah.
Yeah, they should. The bases of those should be toggling. Yeah, if it's trying to run.
And I think Phi 1 and Phi 2 should pretty much always be there.
So that, yeah, Phi 1 and Phi 2. Yeah, so there should be something on the base of those transistors.
Yeah, because the that thing around AR1 is supposed to be the PWM that regulates it.
All right, so I do have some 2N1711s, but they are not the same Q numbers, but I think that's probably okay.
What
These
Q numbers are they?
Q18 and Q19.
Q18, Q19 are any big resistors, 1 watt around there?
No.
Because they're collectors of the two transistors we're looking for on this schematic go through 82 ohm 1 watt resistors.
I mean, I see some 82 ohm resistors. They don't look like 1 watts. They look like half watts, but they might be 1 watts. They're not super close, and they go someplace else.
Because that's what's supposed to connect that pair of diodes to those transistors. And their emitter is supposed to go to ground via 20 ohm resistors.
Sure. I mean, I'm trying to reverse engineer this thing at 12:30 in the morning.
Hey,
by just looking at it.
6:50 here. 6:50 a.m. here, so I really should go to bed. Yeah, I think I'm gonna call it a day.
Yeah, I mean, like, so we know for a fact that we have the 60 kilohertz clock, and we also know for a fact that one of the like main transistors that's going out is very dead because I can actually see inside of the transistor. So I think what I need to do is I need to just go through and make a list of all the parts that are obviously needing replacement. And I'll just place an order, and then next week we'll just swap out the obviously broken stuff and see how it goes from there, right?
Yeah.
That'll probably get us a lot closer, and then I'll go through and clean some stuff up.
You get stuff from Mauser pretty quick, right?
2 days.
2 days.
It's a 2-hour drive to Mauser headquarters, but it's 2 days to get them to ship it here. But I mean,
Now-
I can place the order on Monday, and we'll have it easily before next week.
If they're not too expensive, you might want to order some of the other common parts that are on them.
Oh, I'm gonna make a big list right now.
Yeah.
I'm gonna pull each card out, go through, make a huge fat list, and then tomorrow I'll get on Mauser and just spend money.
So especially the chips as well, because I've had a lot of early like plastic dip packages fail when they had got moist in the past. And I've also seen LM339s fail way more often than I would expect to.
So I've got a lot of 7400 spares, and I even have 339 spares and whatnot. But some of the stuff that I don't think I have spares of are the OC part, the open collector parts.
Yeah, the 339 though is supposed to be, I think it's a can. Not entirely sure. AR1.
Oh,
Well, we'll find that out here in a second. Let me get the expensive oscilloscope out of the way here.
may have
Yeah,
to.
it's definitely a can. It's on the photo next to the multi-vibrator.
Well, if push comes to shove on that, we can take a dip and build an adapter for it.
I wonder if the dog just sell the can still. Might be like twice as expensive as a normal one, but
At least twice.
at least, yeah.
There's my deoxit. Man, I spent ages looking for that. God. Reorganizing your
at
room
least,
is great and terrible at the same time.
So true.
And I've never lost as much stuff as like the period immediately after tidying up.
Yeah. I mean, it's not lost. I still own it. I just don't know where any of it is.
Why is it that things I left in a random pile of stuff months ago I can find instantly, but the stuff I took the time to organize and put in a logical location I can never find?
I searched for 3 days to try and find the cable. I have a cable that plugs into the flexo writer of the LGP21 here, but it's just a power cable. So it just goes into that big Canon connector and goes into the wall. And I'm going to reuse that Canon connector to actually make the real cable that goes to the computer. And I searched for 3 days for that cable and could not find it because I, in my infinite wisdom, put it someplace where I said, this is where it needs to be during the reorganization.
Put it where
I finally
you
found it by accident.
knew you would never find it.
Huh?
Put it where you knew you would never find it.
Yeah. Well, ironically, it was right behind the machine, you know,
Oh,
in a place that makes sense. But it was like, it never was there before. It was always in a specific box. And so I searched in every single box that I own. And it was just, oh man, it was the worst. All right, I'm going to type this up while we go through here.
What
Back-
device type is that 9-pin can? Was that a 339?
Hang on. I don't know which can you're talking about, but
The 9-pin, what looks like a 9-pin.
let me.
Looking. AR1. Trying to find it in the parts list. Oh, let's see, voltage regulator. AR4, AR5.
All right, now that I'm actually at a computer, I can read Twitch chat as well, which I have not been paying attention to for too long. All right, so for certain, you're talking a 9-pin can. Oh, it is socketed at the very least.
Oh,
That is a LM311H.
ooh,
So an LM311.
that's a comparator, isn't it?
Of all the
311.
parts on the board, that's the one that looks the cleanest.
That is a comparator, and it is diode transistor logic, DTL. MOS.
DTL.
I need some 2N3740s. And I
And
need
they
at
are-
least 2 of those.
Analog comparators.
They're made by Texas Instruments and are $17 for Mouser.
You beat me to it. I'm on the Mauser site too.
I mean, do I need one though?
Might
Like-
not be a bad idea to have a spare, but
I mean, if I don't have to spend $17 per part on a bunch of what ifs, that would sure not upset my bank account as much.
$17 for the tin can, 92 cents for the dip.
Yeah, the LM311N is the dip package. I was just about to say that.
Boy, my 3502s are looking a little rusty. Those might also be upset.
I got 183 in stock.
Maybe. The axial caps are all 50-volt 100 mics. So those could all get replaced. Those big grody looking ones up top that have clearly leaked. So let's go 50V 100UF times what? 1, 2, 3, 4 for certain. This is the 5V regulator board, right? Now the smaller caps don't look like they've gone bad yet, but I might order some just in case. Those look like 100 mic 10 volt. Oh, that was a little different. Yeah, these are all going to be slightly unique, huh? What a weird way to market. That says 686K. 7239. NC1C813BD. It's like all the markings on that. Doesn't tell me what it is. So
Which
that's
one
like
is it?
C8, C11, C5.
The one next to the schematic number says 100 millifarad. That's going to be microfarad.
Yeah, if it says
100
MF, yeah, that's microfarad.
50 volts.
Yeah, that's these big guys across the top. I'm looking at the smaller metal cans.
Oh, sorry. I did cross-reference the assembly number for that board, and it matches the engine control module for a Honda Accord.
Nice. Excellent. All right, so I don't think I have any 7403s, 09s, or 121s. I might, though. I'll double check. 4121. Just in case, though, I'm going to go ahead and write those down. I mean, I can't see anything else egregiously wrong on this particular board, except for maybe these big chonker diodes, but I bet you those are fine too. I mean, they're a little rusty, but not too bad.
What's the rectangular metal can towards the bottom of the circuit board?
I don't fully know. It's marked K1.
Oh, relay.
Yeah, I think you're right. I think that is a relay.
But I didn't see any relays on the schematic.
So yeah, we're definitely hitting a revision change problem.
Yeah.
All right, on this guy, what are you? You're 100 mic 50. You're at 225, 225, 225, 225. You're 150. I don't know what you are. So we'll order 3 150s. Other reg. So we know you, so we'll do times 3 for that. And then this is 25V, 200 mics. We know that we have 1, 2, 3, 4, maybe 5 of those. So that's going to be all those metal cans that were very clearly corroded and leaking on this guy. Those all look all right except for this one, which is a 2N37 something. I've also got a little bit of rust on this 2N3055. And what are you? A 2N37. I don't know what that one is. It's got corrosion right on top of the markings, so I can't read it.
Third one in.
Yeah. It's a 2N37 something. And it's the only 2N37 that size on here. So whatever it is, it's unique. There are 2N3766s that are smaller. So this one is clearly different from those.
These circuit cards have a schematic number listed on them. Is that helpful in referencing them to the documentation?
I don't know. This number is 226842. And the other one was let's see here. Let me get up to here. Go. Nope. Let's see. This guy was what? 226837.
Q12 maybe.
I mean, on this guy, I don't see anything else like horrifically wrong.
Could that
Even
third one even be a 2N374D?
Could be. I mean, literally all I can see is 2N37. Everything else is rust.
Oh, okay.
I don't think the rust is through the metal can, so it's probably fine. But I mean, if I'm ordering parts, I would like to order a. That's one that I'm like, maybe I should get a spare of that one.
Q4. It's hard to read the designations on the physical drawing of the board. I don't know. It might be a 374, but that says Q12 though. Wow.
Accidentally throw away the fuse. Oh no, there it is. Yeah, that's not as big of a list as I was expecting, actually. Just a bunch of electrolytics that have clearly gone, and two metal cans that are like clearly injured. Other than that, everything else looks okay, actually. Heck, we might be able to save this. And that'll get us started, at least. We can replace those next week. Give it another test. And then, you know, make a new list for what's broken. I don't think...
Yeah.
And then we'll just piecemeal it slowly, one thing at a time, until it's functional. I mean, I was thinking that it was fully dead, but like we've seen that there's a 60 kilohertz going on. We've seen it's generating some voltages. Like a large chunk of it is functional. I think like that's functional enough. We can work with it. I am going to put it somewhat back together so I don't have pieces flying all over the place in my room here.
Takes up less space.
Yep. Yep, there we go. And then I'm going to plug the cards into it. I mean, the cards have their own set of problems, but that's for future Twitch videos. My IO card is looking particularly rough, but thankfully it's very simple.
Can you show a close up of the part number on it?
It is well, I've got an assembly
Teletype.
number, a logic number, and a serial number. I don't know which one of
That's the
those
current
helps.
loop for the teletype.
Yeah, I'm pretty sure this is just a teletype current loop card.
Too bad it doesn't have RS-232 on it.
Actually, I want it to have current loop because this guy. Actually, wait, that one might be modified for RS-232, but whatever. It's an ASR33, so we can get it to do current loop.
Yeah.
And then we have a
My thought was
half-populated
just-
RAM card.
My thought was just to have CRT on it to bring it up. You know that the CRT, your AMD is working fine, so. Oh, what is that? 12K or 12K words?
I have no idea. It's half populated. I've got another one that is fully populated.
Oh, okay.
So I've got two here.
24.
So these are the two memory boards that I've got. They are slightly different from each other.
Oh.
And let's see here. These are P1103s. And these are, what are these? MF1103s. So they're all 1103 RAM chips, whatever those come out to.
Okay.
My guess is that it's collections of 8K. So I think I've got 8K and 4K here for a total of 12K.
Yeah. 12K, yeah.
Those are 1K Intel PMOS DRAMs.
Okay.
TI was making RAM at that point, so.
It was known as the Core Killer. It was the best-selling semiconductor memory by 1972.
And then we got this guy, which is the memory controller.
Yeah.
Whenever the thing updates, it's only like half of the board. So there are some ICs on here with some pretty crusty looking legs, but we're just gonna assume that everything is functional until proven otherwise. And then our two CPU cards.
Oh, you've got both CPU cards. Great.
Yep. I mean, it's a complete system. It's just not a fully featured system.
Well, yeah, there was the second CPU card was optional, if I'm not mistaken.
Oh, interesting.
So you may have more math on that.
Excellent. Ooh. Feels a little crunchy, but I think it made it down. And then I've got the connector things that go across the top for the CPUs.
Yeah.
Bridges.
Yep.
Bridges, yeah.
And then that is a complete TI-980 that someday will hopefully work. It looks so much cleaner now that it spent 3 hours under the hose.
You should have taken pictures of them before.
I posted a couple up in Friday Night Twitch, and I've got a couple more pictures elsewhere of how nasty it was before. But I mean, there was like a lot of leaves and just junk inside of it.
Jeez.
Yeah, it was not great.
Gross.
I mean, it spent most of its life outside. All right, let's take you and see if I can get to the server. Soggy 1 captures. We're just going to drop it.
KF7 LSU pointed out that the extension port supports current loop on the ADM3A.
Yeah, it might. I think so. If it doesn't, the Centurion terminal that adds Regent 100 supports current loop. So
that
we
might
can
be a good starting point, so that because you know those work.
Yeah. Pretty much my plan was that if we can, using the front panel of this thing, see that it's mostly functional, then we're gonna switch gears over to the ASR33 and bring it up fully, because I really want to bring it up anyways.
Yeah. There are a few routines you can key in quickly for memory testing and such.
Yeah, I mean, we don't even have to go that hard on it, because the ASR33 is going to be as much of a challenge, if not more, than bringing this thing up was.
Yeah.
Yeah. Boy, that turned out looking way nicer. It hadn't looked that clean ever. And we got more cleaning to do on it. Ah, all right. I think it's time for me to go climb into bed. But I will post this picture of where we got to today. That's pretty righteous. Far more of it was alive than I was expecting. I am very, very pleasantly surprised.
After seeing that thing, I'm surprised myself.
Yeah, I mean, it was gross. It was rough. Diaz Knox, I mean, everything is a calculator, you know? Depends on what your definition of a calculator is. It could do calculations.
I noticed the switches are in groups of 4. Does that mean this is a, hexadecimal machine?
I do believe so.
Yes, it is hex.
Nice.
I hate octal.
It feels. It feels much more. I was gonna say it feels much more like a normal processor compared to the TMS 9900 or the TI-990. Like you have your, standard traditional registers that are on the CPU. It's all 16-bit,
right.
Bus based. You got regular old sense switches. Like it feels like this is much closer to something that I would expect out of like Centurion.
It's the kind of machine I was brought up on.
It's what?
It's the kind of machine I was brought up on.
Oh, on a TI-980?
Yeah. Well, I worked at TI in Stafford. That should tell you who I am.
Oh, excellent. Wait, do I know you? Have I met you?
No. Well,
okay.
We've talked on chat, and that's all.
Oh, but you haven't been to like VCF Southwest or something?
No.
Oh, okay. A lot of the TI guys often swing by the VCF, and I've met quite a few people that have been through various different places at TI.
I only spent a few years in Texas. I was at TI Stafford for 4 years,
Okay.
then moved to Digital Systems Division in Sunnyvale, California.
Oh, okay.
That's where I got most of my work with the 980 and 960.
In California, ironically. That's fun.
Yeah.
I did meet Dr. Granville Ott, who I think had a pretty heavy hand in both the 960 and the 980 development.
That name does ring a bell. Not exactly, but it does ring a bell.
Yeah, and then he ultimately got moved on to the TI-99 project. And it was hilarious talking to him about that because it just kind of confirmed all of our suspicions that it was kind of hell at TI during that time on the TI-99. Yeah.
Well, the 9900 was based on the TTL version, which would be the 990/10, which has the same instruction set.
Yeah. And that actually got used first, I think, in the 990/4 as the cost reduced version of the 990/10.
Right, that was the LSI version.
Yeah. And I think it was a little slower. I think the 10 had a faster clock speed because the TTL stuff was
Much
booking.
faster. Much faster, yes. I've worked with both the 4 and the 9. Or the 4 and the 10.
Okay. Well, like the ironic thing here is that I've been looking for, see if I can get my face on camera here. I've been looking for a TI-990 for years.
Yeah, I've heard that.
Yeah, I was searching for a TI-990 when I stumbled across the Centurion. And then, you know, I kind of dialed back my search for a TI-990 while I was working on the Centurion. And then once the Centurion project got to a point where we were mostly complete with it, I started up looking for a TI-990 again. And there were a couple opportunities that I just slightly missed out on. Bob had a 990 with a Hawk drive up at the museum in Maryland, and I was like, ooh, I really want this, but we never worked out a way to get it down to here. And I was kind of like, all right, I'm really jonesing for a 990, and this dude walks up to the local meetup here in Dallas and goes, you know, hey, I've got some stuff in the van. You want to look? And somebody came and grabbed me and was like, hey, you got to check out this dude's van. And he had this 980 in the back. And I was like, well, I mean, that's cool. And so I just gave him all the money that I had in my wallet, which was like $160 or something. It was just like, that just happened to be what I was carrying in my wallet. And he was like, it's good enough. And so then now I've got a 980. So now my search for the 990 has kind of dialed back again. So it's just like the 990 is my white whale. I'll never get one, I think.
To find a 990/10 is probably going to be near impossible, but
yeah, I mean, I would be happy with a 990/4 even, because I really like the TMS 9900 chip. You know, in general, I think it's a really cool chip. But yeah, well, I mean, at this point, I've got a TI-980. Like, why do I need a TI-990? You know, I've already got one TI Mini. I don't need another TI Mini.
I worked for a company that basically made not core, but solid state memory versions of the IBM 1130, I think. Anyway, they also decided that they were going to get into minis, and they started out with the 990/10 and 990/4. So that's where I got my experience with the 990.
Okay. Chloe Raccoon. Yeah, I was literally like cruising all of the Facebook buy and sell groups for like vintage computers, and somebody posted up a Facebook Marketplace ad for the Centurion, and nobody knew what the Centurion was. It was just like this completely forgotten mini computer, and the comments were hilarious because people were like, "That's a nobody knows anything about that. It'll never come up. What a useless piece of junk. It's only worth the scrap value." And the dude listed it for $100, and it was in Oklahoma, which is like a 6-hour drive from here. It was in Muskogee, and so I sent the guy a message, and I was like, I mean, I can spot 2 ads terminals and 2 19-inch racks, so at the very least, like it's worth $100 for that alone, right? And so I shot the dude a message, and I was like, I am interested. We can be there on the weekend. And he was like, cool, come. And so we drove up with the truck, and we loaded that truck chock full. And it was 2 cabinets, a Hawk drive that was so destroyed we couldn't fix it. It became a parts drive. The Phoenix drive, which was crashed. The printer, 3 ads terminals, 20-something disk packs. I mean, it was like, what an insane deal, right? And really? Then, once we brought the whole thing up and cleaned it up, and it turned out that the computer was like totally fine. People started becoming aware of like the Centurion story. It's been like the feedback then has changed quite a lot. Like the how people view the Centurion mini computer has kind of changed a little bit. I don't think you would get many people finding a Centurion and going, "Oh, that's only worth scrap value" anymore. Just because we've raised enough awareness about the machine and the history of it, and it's had enough attention placed on it that I don't think anybody would try to sell a Centurion for scrap value anymore. Then again, I don't really think they're worth all that much. It's not really a super special mini computer. I think it's a attractive mini computer, but that's about it.
Business based is the unfortunate part.
Well, and it was small to medium business based, and their bread and butter was accounting, and they had a really good oil and gas package. Not oil and gas from a research and scientific standpoint, but oil and gas from a like management and accounting standpoint. So that was kind of their bread and butter, and they did really, really well in both of those fields. They tried to get into the automotive field with like parts management systems and stuff like that. And who was the other company? Triad, maybe? There was another company that was already in the automotive field that just mopped the floor. It was Centurion. So they tried to break into the automotive field and then immediately got their butts handed to them, and we're like, nope, we're done with that. And as I understand it, to get it back to the TI talk, the TI-980 was used much more heavily in kind of a research and development and scientific area.
Yeah.
Whereas the TI-990, I'm not entirely sure what they were used for. Small to medium businesses, I think.
Yeah, I think they're more used for like business stuff than like technical stuff.
Yeah. So having the 980 in here in this room with the current vibe is actually a much better fit.
Well, the one thing I saw that 990 used for was for the FLIR power supplies on the FA-18 Hornet. The test bench had a 990 in it.
Yeah, I guess they were used for used for some of that kind of thing too. Like they had like a simple like floppy based real-time OS TX-990, which is like then like the bigger machine that was like on the 990/4, like the 990/10 and 12 ran like DX10 and DNOS, which are like vaguely IBM like.
Yeah, it was the power supplies were made by Texas Instruments, so they made the test bench too.
Well, also I think the TI-990 architecture is a derivative of the F-16 architecture, control computer architecture.
Really?
Yeah, I that's what Granville Ott was saying, is that the team that, so the Texas Instruments developed the F-16 computer, flight computer or whatever, I don't know. They developed something in the F-16, and that architecture bled down into the TI-990 CPU architecture, which ultimately bled down into the TMS-9900. That was the story I heard from Granville Ott. I don't know how accurate that is, but that was what he was saying.
That would have been the mission computer, probably.
Okay.
You can cross assemble for on the TI-980 for the TMS-9900.
Yeah, I saw that. You sent me that link. That's for, you can assemble TMS-9900 code on the TI-980, not vice versa.
Right. It's but the fact that they were doing it back then is pretty freaking awesome.
Yeah. Yep. All right, y'all. It's past 1:30. I need to go climb into bed. Thank y'all for joining. We'll be right back on this next week, hopefully with new parts, and maybe we'll see some more life out of it. That'll be exciting. But thank you all for joining. We'll see you next week.